Hello.
కట్టుగానే చాలా కొంచెం పట్టుకో హైడ్ చేసుకో
Good morning to one and all. I extend a warm welcome to all the esteemed delegates, principals, vice principals, research scholars, students of various colleges to this 3-day international conference on biomedical research for global health, advances, opportunities and challenges, organized by Department of Zoology, sponsored by 𝕃𝕀𝕍𝔼. We are very much honored to have with us academicians, subject experts, researchers, eminent speakers for this session, for spending their valuable time to share their knowledge with us. And your presence has made this occasion and enriched this occasion and added grace to this occasion, sir. Thank you very much for the esteemed speakers who have reached here. Today's seminar conference is the importance of the theme is the biomedical research for global health, advances, opportunities and challenges. We all know that biomedical research is not just about science, it is connected with biology, medicine and technology. Biomedical research helps us to understand the fundamental processes of biology, helps us to develop new diagnostic tools, new medicines for effective treatment of various diseases to increase the quality of life. We all know that there are so many global health challenges which the world is facing. One such challenge is COVID-19, which we have experienced through where number of people have been died because of pandemic COVID-19. During that time, just because of biomedical research, the biomedical scientists are able to develop vaccines within a short period of time and saved millions of people across the world. Similar such global health change now prevailing all over the world is antimicrobial resistance. Nowadays, the bacteria are getting resistant to many medicines. So much of research has to be done to develop new drugs to fight with life-threatening infections. So biomedical research is the need of the day, and it is essential to build a healthy and safer world. And this, I hope that this 3-day conference will help you in broadening your understanding about the biomedical research, in taking up new research ideas in the young minds of research scholars for the benefit of the society. With these few lines, it is the time to invite the dignitaries onto the dais. At the outset, I extend a warm welcome to the President of this conference, Honorable Principal, Professor G. Srinivasa Garu, on to the dais, please. I request Swami sir to honor him with flower pot and Harshita to pin the badge. Okay.
See, photo. Oh, take it, book. Kumar, photo.
I take privilege to invite the co-chair of this conference, Head Department of Zoology, Associate Professor Dr. 𝕃𝕀𝕍𝔼, onto the dais, please. I request Raghu sir to honor him with flower pot.
Please.
I request and I extend my heartful welcome to the Vice Principal of Arts, Dr. 𝕃𝕀𝕍𝔼 sir, onto the dais, please. He always strives for the academic growth and excellence of the institution. I request the convener of the conference, Dr. Rohini ma'am, who has done tireless efforts for conducting this seminar, onto the dais, please. I request Prasanna ma'am to honor her with flower pot. I take privilege to welcome IPSC coordinator of the institution, Dr. A. Srinath sir, onto the dais, please, who always sets benchmarks for the quality education in the institution. I request Chinna sir to honor Rashid with flower pot. I request Shyam sir to honor Srinath sir with flower pot. I request the dignitaries to proceed towards lighting of the lamp, followed by the prayer song by Dr. Nagamani ma'am, Associate Professor of Hindi.
फैन आप दिए
कुमार इनका ग्रह है
Thank you. Thank you, ma'am. I request all the dignitaries to be seated on the dais. I thank all the coordinators and members of various committees for assisting Department of Geology for smooth conduction of this inaugural session. Now I hand over the proceedings to the President of this conference, Professor J. Srinivas sir. Thank you. I'm back to the welcome session. I request Professor Venkateswar sir, Department of Geology, Kakatiya University, to please come on to the dais and join with us. I request Raju sir to honor him with flower pot. Thank you, sir. Respected Chief Patron, Dr. Yogitaran IAS, Secretary, Government Education Department, Government of Telangana, District Patron, Srimati Yuvasena, IAS, Commissioner of Quality Education, Government of Telangana, Esteemed Patron, Dr. Soundarya Joseph, State Project Officer, 𝕃𝕀𝕍𝔼, Distinguished Chief Guest of today's inaugural session, Professor K. Pratap Reddy, Honorable Vice Chancellor of the University of Warangal, esteemed keynote speaker, Professor K. Srinivasa sir, Virginia School of Medicine, United States of America, respected guest of honor, Professor Suresh Kumar Ayala, Indian Institute of Technology, Madras, respected Cabinet and Organizing Secretary, Dr. P. Rohini, and the co-chair of this inaugural session, Dr. T. Dinesh, Head Department of Zoology, district members on the days of the days, dear colleagues, research scholars, participants, and dear young students. Good morning to all. It is a matter of great privilege to preside over this international conference devoted to the theme Biomedical Research for Global Health, Advances, Opportunities and Challenges. This gathering reflects our collective commitment to advancing science that not only generates knowledge but also addresses urgent societal needs. The 21st century has demonstrated that biomedical research is not a peripheral academic pursuit. It is central to national security, economic growth, and human well-being. The sequencing of the genome of SARS COVID-2 and the rapid development of advanced vaccine platforms during the COVID-19 pandemic stand as remarkable milestones in modern science. Indian pharmaceutical leaders such as Bharat Biotech, Serum Institute of India, and Zydus Life Sciences demonstrated how research, innovation, and manufacturing capacity can coverage to serve human at scale. These achievements were enabled not only by scientific brilliance but also by sustained governmental vision and policy support. My dear researchers and students, when we observe strategic vision and national institutes of Government of India, the Government of India has, over the past decade, significantly strengthened the biomedical research ecosystem through coordinated policy,
funding and institutional expansion. The Department of Biotechnology has spearheaded major initiatives to promote genomics, vaccine development, and translational research. The Genome India project is creating a comprehensive reference genome database representing India's diverse population, laying the foundation for precision medicine and predictive health care. The Indian Council of Medical Research has expanded National Clinical Trials Network, strengthened disease surveillance systems, and enhanced laboratory infrastructure, including advanced biosafety facilities. These investments ensure preparedness against emerging and re-emerging infectious diseases. Mission, more programs such as the National Biopharma Mission have fostered public-private partnerships to accelerate indigenous innovation in biologics, biosimilars, medical devices, and diagnostics. Budgetary allocation in recent years have further emphasized strengthening biopharmaceutical research, clinical research infrastructure, and skill development in life sciences. Complementing national efforts, the government of Telangana has positioned the state as a premier life sciences and biomedical innovation hub. Hyderabad's Genome Valley stands as one of the India's earliest and most successful biotechnology clusters, housing research institutions, multinational pharmaceutical companies, and biotech startups. Telangana's life sciences policy has provided strategic incentives, world-class infrastructure, and regulatory facilitation to attract global investments in biotechnology, pharmaceuticals, and medical research. The advancement of biomedical research is a shared responsibility of governments, institutions, industries, and scholars. As Albert Einstein stated, concern for humanity and its fate must always from the chief interest of all technical endeavors. Scientific progress must be guided by compassion and industry. The advancement of biomedical research is a shared responsibility. Together, they form a systematic model for scientific growth and societal benefit. Let us reaffirm our collective resolve to pursue biomedical research with integrity and excellence, to strengthen India's and Telangana's contributions to global health, to ensure equitable access to healthcare innovations, to nurture the next generations of scientists. With great optimism and academic pride, I firmly declare this international conference inaugurated. May the deliberations for these 3 days inspire transformative ideas and enduring collaborations. Thank you, one and all. Jai Hind. Now I request Dr. P. Rohimam, please briefing this 3 days conference, please.
Respected President of the 3-day International Conference on Biomedical Research for Global Health, Advances, Challenges, Opportunities and Challenges. Professor G. Srinivasa, Chief Guest, Honorable Vice Chancellor of Kakatiya University, 𝕃𝕀𝕍𝔼 sir. Keynote Speaker, Professor Karanam Srinivasmurthy from Virginia Commonwealth University, USA. Professor 𝕃𝕀𝕍𝔼 sir, Guest of Honor from Indian Institute of Technology, Madras. I am Professor Y. Venkaya, Head Department of Zoology, Kakatiya University. Vice Principal 𝕼𝕼𝔼 Madam. Vice Principal from Arts 𝕼𝕼𝔼 sir. And Head Department of Zoology Dr. T.D. Dinesh sir. IPC Coordinator Dr. Srinath sir. And all other dignitaries of the dais, faculty from other institutions, research scholars, students. Good morning to all. I once again extend a warm welcome to you all for this 3-day international conference. So this conference is a brainchild of both me and my supervisor, Professor 𝕼𝕼𝔼. So in this conference, so as you all know that biomedical science is an interdisciplinary approach where both life sciences, chemistry and physical science all together, it is a combination of all these sciences which will help in to know how diseases will occur at the molecular and cellular levels. So in this conference, we have a keynote address from Professor S. 𝕃𝕀𝕍𝔼 sir, and later on we have 12 invited talks from eminent professors from various institutes and universities from other states and including our state. We have one invited talk from Madras, and the next is from, the second invited talk is from Dr. Sridhar, he is an Ayurvedic doctor, and the third is from, invited talk is from Professor 𝕼𝕼𝔼 of Kakatiya University, and the fourth invited talk is from, it is an online talk from Texas A&M University, Dr. Samba Reddy, and the fifth one will be from Professor A. Uma, JNT from JNT, and the next talk will be from Professor Roja Rani, Department of Genetics, Osmania University, followed by an invited talk from 𝕃𝕀𝕍𝔼, Dr. 𝕃𝕀𝕍𝔼. He is from ICMR, National Institute of Nutrition. And the next talk, invited talk, is by Professor 𝕃𝕀𝕍𝔼. He is from University of Hyderabad. Followed by talk from 𝕃𝕍𝔼𝔼 Madam, Professor 𝕃𝕍𝔼𝔼 from Kakatiya University. On the day 3, we have another online talk from Professor G. Chandramouli from New York, and next followed by Professor P. Srinivasa from MIT, Professor R. Satish Babu from MIT, and Professor Y. Venkaya from Kakatiya University. So we have 12 invited talks and oral presentations on all the 3 days and poster presentations. So I deeply think that all the deliberations that go on in this conference will certainly lead to academic exchange, knowledge exchange, and it may lead to global partnerships and will into new research initiatives. I once again welcome all of you to this conference and I see that all of you gain knowledge from this and go from this conference. Thank you all. Thank you, sir, for giving the opportunity.
Thank you, ma'am. Thank you so much for your interest of this 3 days this conference. Now I request Professor Vakir sir, please address the gathering.
Good morning to all of you. The principal, Kakatiya Government Degree College, Dr. Srinivas Garu. Today's organizing secretary, Dr. Rohini Madam Garu. Today's this 3 days international conference keynote addressee, Srinivas Murthy Garu, and another guest of honor, Suresh Garu, R. Suresh Garu, and Vice Principal Madam, Vice Principal Sir Rajkumar Khan, and other dignitaries on the dais, and off the dais, different colleges, lecturers, professors, associate professors, and madams. Different subjects are in this college and various colleges of our Kakatiya University jurisdiction. And my dear students and participants, delegates, press and electronic media, very good morning to all of you. I congratulate the organizers for conducting this 3-day international conference. So this is the second or third conference of my college. This is the second or third conference. I hope English department also conducted one international seminar. So our department conducted international seminar. I could say proudly, it is a great honor to the college, and all the participants came here. They have taken a lot of pain and came here to spend 3 days international conference. And also, conducting of international conference is not a small thing. It is very big task because of organizers take very lot of pain and so many hurdles they have to face because of inviting guests and other hospitality arrangements take very difficulty today. So, but they pain all these activities, but they conduct the international seminar. I congratulate the Rohini Madam and his team and Principal Sir and his team for taking a lot of hard work for conducting this international conference. So I hope these 3 days deliberations will enrich the knowledge for the students, faculty members and other research scholars will help these 3 days deliberations. I hope the successful conduction of this international conference. Thank you for giving this opportunity. Thank you, sir.
Thank you, sir. Thank you so much for your inspiring words with respect to this program, and as well the programs are conducted by the Kakatiya Government College Autonomous 𝕃𝕀𝕍𝔼 as well. Thank you, sir. Thank you so much. Now I request our Vice Principal, ma'am, please address the gathering.
The President of the program, Professor G. Srinivas sir, Principal, Kakatiya Government College, Autonomous. Keynote Speaker, Professor K. Srinivas Murthy, Virginia School of Medicine, USA. Guest of Honor, Professor Suresh Kumar sir, Regala, Indian Institute of Technology, Madras. Head of the Department of Geology, Dr. Dinesh sir. And Head of Department of Kakatiya University, Dr. Venkaya sir. Organizing Secretary, Dr. Rohini ma'am. Vice Principal, Dr. Rajshekhar sir. IKC Coordinator, Dr. Srinath sir. And all the faculty of Kakatiya Government College Autonomous and lecturers from various colleges, researchers and dear students. Good morning to one and all. At the outset, I congratulate Department of Geology for organizing this 3-day international conference on biomedical research for global health, advances, opportunities and challenges. The key purpose of this conference is to disseminate knowledge by expertise talks by various resource persons. I heard that Madam has arranged 12 lectures and also to connect you with your peer groups globally, to update your skills by learning new methodologies and also to gain insights in emerging industry trends, to give you a scope for sparking new ideas through interactive sessions and discussions on cutting-edge topics. I hopefully these 3 days gives an enriching experience which is memorable to you all. Thank you all.
Thank you so much for the valuable work. Now I request Dr. Rajshekhar sir, please address the gathering.
Respected President of the session, Professor J. Srinivas sir, Principal of this college, and Chief Guest, Keynote address speakers, and the distinguished personalities on the dais and off the dais, heads of the departments, and esteemed faculty members, and my dear young researchers and students of this college. So first of all, a very heartfelt congratulations to the organizing secretary, Dr. P. Rohini Madam and his team. And it's a very greatness of this college conducting a 3-day international conference organized by Department of Geology. It's not a simple task conducting an international conference, because today we are in the era of the digitalization, the technological revolution. Whatever may be the stream, whether it is a medical or any other area, it's booming up. And India is a country where we are heading towards the global standards. And not only India, even in Telangana, and also Warangal district is also heading towards such rapid developments. In this context, the Kakatiya Government College is always a forehead in conducting such a great academic events, and all the faculty here are well versed and they are contributing to the academic revolutions. So in this, once again, I welcome you all to this 3-day international conference, and all the deliberations will be fruitful, and definitely this will become an academic successful event. On behalf of the college, Kakatiya Government College, I once again thank you all for coming to this event. Thank you very much.
Thank you, Rajshekhar sir. Thank you so much for your inspirational speech. I have a request. IKC Coordinator Dr. S. Srinath sir, please brief the gathering.
Respected. Good morning all. Respected and beloved Principal Professor G. Srinivas sir, and today's chief guest, Professor K. Srinivasmurthy garu, who has come all over from the USA, so Richmond Commonwealth University, Virginia, and another professor, Professor R. Suresh, IIT Madras, and today's organizing secretary, Dr. Rohini Madam, and all the dignitaries on the dais and off the dais, a very warm welcome on this august gathering to this 3-day international conference by Department of Geology. And I would like to congratulate the department and the team, and particularly a special thanks to our principal sir, so who has extended his kind cooperation for organizing this 3-day international conference. And this conference is being telecast on YouTube thanks to Dr. U. Swami sir. So he has created a YouTube channel. This conference is not only just offline mode but a hybrid mode. And even though this is a macrocosm in microcosm, so we are in the macrocosm here in this small room, but the deliberations and this event proceedings are being telecast on YouTube. That is more popular. And thanks for everyone for giving me this opportunity. Thank you.
Thank you, Srinath. Thank you so much for your words. And also you have remembered us. The program is still telecasting from YouTube. Nice, right? And I request Dr. P.D. Dinesh, the Department of Zoology, please address the class.
Good morning, all. Respected Principal Garu, Professor J. Srinivasarao, and all the vice principals, Dignitary Madam and Rajshekar sir, the convener Rohini ma'am, and on behalf of the Department of Zoology, myself and all the faculty members, we wish you a warm welcome, and we also thank all the members of all the committees who have been working tirelessly for the last 2-3 days in putting up this show, and also our friend Swami Garu for streaming this, for making this a live stream, so that students, teachers and scholars who are interested in this program can also see it all over the world. Thank you, sir. And this is the main platform where interdisciplinary research is being shared among all the researchers, students and teachers. This will help us to enlighten ourselves, to know new things, new techniques, and also sharpen our brains and minds. And this is a platform to bring about a diverse community of academicians together to share our thoughts. And in the backdrop of this conference, I once again thank our apex authorities, the Commissionerate and the Secretary, College of Education, for supporting us, and also they are the sponsors of this program, PM Usha. So thank you, ma'am, for all the support and also for the financial support. Thank you once again, and we wish all of you will benefit from by attending this conference. Thank you once again.
Thank you, sir. Thank you so much for your valuable words. Now I request Professor Suresh Garu, IIT Madras, please address the gathering, sir.
Okay. Good morning to one and all. First of all, let me thank all the organizers for having made so good arrangements for us to be here. And I wish the team all the best, and I'm sure that this 3-day program will enlighten students and faculty to learn a lot of knowledge and gain a lot of knowledge, and they'll go with a fruitful hope from here. Thank you. Thank you, sir.
Thank you so much for your introduction, sir. Thank you. And I request Professor Srinivasarao, sir, please address the gathering.
Good morning, students and faculty. I also want to thank the organizers for the invitation, and I wish this 3-day conference will enlighten all the students and occupy one of the spaces. Only 7
మీరే చెప్పండి మీరు ఏం చెప్పాలి కదా నాకు ఫోటో థ్యాంక్స్ చెప్పాలా
Good morning once again. I thank the principal and keynote speakers and chief guests who have come all the way to bless us in this 3-day international conference. And thank you once again for attending this 3-day international conference. I request Principal Garu to continue the proceedings. I request keynote speaker Professor K. Srinivasmurthy Garu to address the gathering.
keynote speaker
Now I request Dr. 𝕃𝕀𝕍𝔼 Madam to introduce the keynote speaker.
కింద పార్టీషన్
I take privilege to introduce today's keynote speaker and chief guest of inaugural session, Dr. Srinivasmurthy Garu, a distinguished academician and researcher in the field of physiology. Dr. Murthy sir obtained his PhD in 1984 from 𝕃𝕀𝕍𝔼 University, Tirupati. Following his doctoral studies, he began his research career as a senior research assistant at the Central Sericultural Research and Training Institute, Mysore. He then moved on to the United States to pursue advanced research, serving as a postdoctoral fellow at the University of Mississippi and subsequently at the State University of New York, Stony Brook. He later worked as a research associate at the Medical College of Virginia. Dr. Murthy joined Virginia Commonwealth University, where he served with great distinction, progressing from assistant professor to associate professor
Good morning, everyone. Can you all hear me? Please follow me. Students, can you all hear me? Micro. Are you okay? Is it okay? Please follow that. I want to thank Dr. Rohini ma'am and I for taking the effort and making this organization. Just want to let you know one thing. I never met her. He has been asking me for the last 1 year to come and deliver this sponsor. She took a lot of effort to do that. And of course, behind that, she has the support of your principal and all that. And you should be really lucky to have faculty like this. Okay, students can hear me. You should be really lucky to have faculty like this. And Srinivasan, you should be proud of your faculty. Okay, the topic of my presentation is molecular basis of medicine. What I'm going to do is give an overview to understand the molecular targets of medicines or drugs that we use today to treat various diseases. Before that, I want to know how many of you are undergraduates with science faculty. Rest are postgraduates. How many are postgraduates? So that I can adjust my. So you all know some basic science, right? You all know what is a hormone. Hormone at the top. But you know the medicines, some of the names of the medicines, right? Can anyone name one medicine? Any medicine? Students, not the faculty. Insulin, very good. Very good. Insulin is a hormone, it's a medicine, right? It's a hormone also. What do you take it? Increase the amount of insulin? Diabetes. What else we take for this? Diabetes. Any other medicine? We take so many drugs for insulin. I mean medicine, diabetes. One is insulin. That is a hormone. And 𝕃𝕀𝕍𝔼 or something, right? And metformin. And the latest drug, what is that? The wonder drug. Ozempic. So many drugs are taken for diabetes. Likewise, we take so many drugs for hypertension. You may not be taking the student, but your parents may be taking medicines for diabetes, hypertension, and other diseases. Okay. So all these drugs, all the medicines act on selective locations. Understanding the science behind this is important to target a medicine for that particular location or the current disease. That is what the molecular basis of medicine is. How do I change them? Pointer design. Okay, that's okay. So here I listed various drugs, this column, and the targets on the left hand side. The targets, the nomenclature, okay, for the targets are receptor, we want to know what these targets are. Okay. Why these drugs used for these various diseases are acting a particular location. That's what this point. And this are number. So these are the diseases and these are drugs, some of the drugs we use, and these drugs act on very selective locations, if not very specific. Selective locations where the actions are cells in the body communicate with each other. The cells don't function in isolation. Very important to understand. Okay? The cells in the body do not function in isolation. Good examples. Skeletal muscle. Always listen to neurons. Without neural activity, there is no muscle activity. Voluntary muscle, skeletal muscle. If you don't want to lift up, you don't lift up, right? So the muscle cells are slaves to the neurons. Cells communicate with each other. A good example for that is gastrointestinal system. Okay? When you eat food, what happens? Gets into the stomach, very minimum digestion happens, okay, very little digestion, and most of them partly digested or partly ground, nothing, no digestion. You take what? You take carbohydrates, complex carbohydrates, proteins, and fats, right? Lipids. And these, they have to be digested. You cannot absorb carbohydrates. You cannot absorb proteins. You cannot absorb lipids. Carbohydrates, they have to be completely digested to monosaccharides, glucose, fructose, glucose. Okay? And proteins, they have to be completely digested to amino acids. Lipids to fatty acids. So that digestion doesn't happen in the stomach, but there's partly grinding or the mechanical digestion happens in the stomach. Most of the digestion products that enters the intestine, okay, the duodenum are intact. The digestion happens in the duodenum. What do you need for digestion? Digestive enzymes. Recognition of the pancreas, good. But is there a link from duodenum to pancreas? physical link unna kuda, how does the intestine communicate with pancreas? Okay, the point here is the intestine has to communicate to the pancreas, right? That communication is mediated through a chemical substance. The point here is the intestine communicates with the pancreas to release the digestive enzymes. Atlane, when the carbohydrates are digested, glucose comes, right? The product, the proteins are amino acid comes. So the glucose gets absorbed. When the glucose enters the blood, what happens? There is rise in glucose. When there is rise in glucose, what we need? What we need when there is rise in blood glucose levels? Insulin. Insulin comes from pancreatic beta cell. So again the intestine has to communicate to the pancreas. Hey, I absorb lot of glucose. There will be lot of glucose in the circulation. You need to secrete insulin. That's what the intestine tells the pancreas. There is communication again. So in every physiology, in every organ system, there is a proper proper physiological functions. The cells communicate with each other, right? And this communication is known as chemical communication because these are chemical substances. Depending on the cell that releases these chemicals, how they are transported to the target organ. For example, if you take the intestine, that is the signaling organ or the signaling cell. That is the one that says, yes, I don't have digestion food. I need digestive enzymes. When the food is digested or when carbohydrates are digested, there will be a lot of glucose. So you need to tell the pancreas to release insulin. So the intestine is the signaling cell. The pancreatic cells are target cells. Okay. So based on the signaling cell, how the chemical is transported to the target cell, we categorize the chemical signaling to 3 or 4. That's the major ones. Important point here is the cells in the body communicate with each other for proper physiological function. It's a must. Okay. And based on the cell that releases the signal, and the cell that receives the signal, we call them as signaling cell and the target cell. The signaling cell releases the signal in the example case that could be intestinal cell, and the target cell receives the signal. In the example that is pancreas. Okay. There are 4 types of signals. One is neurocrine signal, other one is endocrine signal, paracrine signal, and autocrine signal. Let us see what happens. Neurocrine signal is the signaling cell is a neuron. Target cell could be any other cell. Okay. The signaling cell is a neuron. The targeting cell could be any other cell. The first example I gave you, skeletal muscle. The target cell is skeletal muscle. The signaling cell is neuron, a motor neuron, a voluntary neuron, right? Motor neuron. So a signaling cell, neuron, a target cell, any other cell. That is a neurocrine. Good example is, again in the case of skeletal muscle, acetylcholine. There are so many neurocrines. There are some list of neurocrines. No need to worry about it, but the signaling cell is a neuron. Similarly, a different type of chemical signal, that is the endocrine. Example is, go back to insulin. Okay. Here, the signaling cell releases the signal into the bloodstream. When the signal is released into the bloodstream, it is circulated through the blood circulation and reaches the target cell. We go back to our example, the intestine. It releases chemical signals into the bloodstream, and the signal reaches the target cell. The target cell is pancreas. Okay? And the examples there are the intestine releases many hormones, and they reach the target cell. When it is released into the bloodstream, that is called hormone. When the signal inside is neuron, that is called neurotransmitter. Okay? These are the chemical signals. Sometimes, again there are some examples. A good example I can insulin. Okay? And adrenal rush, right? That's also a hormone. Another type of signal is paracrine signal. Here the signaling cell and the target cell are very close by. So when the signal is released, they reach by simple diffusion. When it released into the bloodstream, it's a hormone, but travels through the diffusion, that is the paracrine. In this case, the signaling cell and the target cell are very close to each other. You have seen neurocrine, endocrine, paracrine. There is not a crine also. Signaling cell, the target cells are the one and the same. So the cells communicate with each other by means of releasing signals, depending on the cell that releases the signal and how it is transported. We divided these chemicals into four types: neurocrine, endocrine, paracrine, and autocrine. Okay. So now the signaling cell, signal is released and it reaches the target cell. Right? The problem here is, let's go back to the yes. There is one problem. All these signals, they reach the target cell, but most of the signals, they cannot pass through them because our cell membrane is bilateral here, and many of them don't have access to oxygen. How does they communicate the signal? The target cell have special molecules to receive the signal. The molecule that receives the signal is known as receptor because it receives the signal. That's what I showed here. Okay? The receptors receives the signal. Why? Because the signals cannot pass through the plasma membrane. You already covered one of the targets for the molecular medicine, right? The receptor. When the receptor receives the signal, it processes the information across the plasma membrane and through the cytocellular spaces. Through a series of steps, we call that signaling cascade. Okay? And this signaling cascade ultimately lead to cellular responses that could be growth, muscle contraction, proliferation, okay, secretion, any other things. So let me summarize that. Cells need to communicate with each other for proper physiology, and this communication is mediated through chemicals, and these chemical signalings can be divided into 3 or 4 types depending on the cell that secretes and the way it is transported. Neurocrine, endocrine, paracrine, or autocrine. And many of these signals are impermeable, right? They cannot pass through the membrane, and they are received through the plasma membrane. They are like antennas on the plasma membrane through these special molecules known as receptors. And when the receptor is activated, upon binding of the signal, it initiates cascade, yes, signaling cascade. And these receptors come in various flavors. Okay, the classification of these receptors are ligand-gated receptors, G protein coupled receptors, tyrosine kinase receptors. I will explain what are those. Ligand-gated, G protein coupled, and tyrosine kinase. Let us see what is ligand-gated. Ligand also means signal. Signal gated. What is gated? This is a channel, open. Okay. Generally, this channel or this opening is closed. When the signal binds, the channel is open. It is closed in the option of filter. When the signal, the chemical signal, could be a neurotransmitter, hormone, or a character, when it binds, the channel opens. What happens when the muscle, the channel or the plasma membrane opens? Transport of ions happen. Okay? The concentration of ions, sodium ions, potassium ions, calcium ions, chloride ions, they are very tightly controlled from extracellular spaces to the intracellular spaces. When the channel is open, the ions flow through. Okay? Depending on the channel type, either you get sodium ion influx or chloride ion influx, chloride ions coming in, or calcium ions. Okay? The ultimate goal, to make it very simple, the ultimate goal is to change the intracellular calcium chloride. The point here is ligand gated means these are channels. In the absence of a signal, they are closed. The presence, they are open. The channel is open. There is an exchange of ions. The ions are sodium, potassium, chloride, and calcium. Ultimate goal is to change the intracellular calcium level. Very important for many cellular functions. This is one type of receptor. Okay? We have seen in the targets some of the channels, right? The drug targets also include channels. For example, the hypertension, amlodipine is a calcium channel blocker. There are many drugs that act on sodium channels, like what we use for pain. They block the sodium channels. Okay? The many drugs act on these channels. What they do is they block the channels. Sometimes they open the channel. Okay? The second class of receptors is G protein coupled receptors. In this case, the many drugs, nearly 50% of the medicines we use act on these types of receptors. They are called G protein coupled receptors because the receptor is a simple protein. It's a transmembrane protein. It passes through the membrane 7 times. Also known as serpentine receptor because it looks like a snake. That's why they call it serpentine receptor. Okay? So it's a simple receptor without any channel or any enzyme activity. But when the ligand binds, it activates. The important feature of this receptor is this one is coupled to a protein known as G protein. Okay? Because this protein always whether the binds to either GDP or GTP, and downstream of this G protein is an effector. And this G protein, when it is bound with GTP, it is active. When it is bound with GDP, it is inactive. The G protein is always bound with either GDP or GTP. Okay? This is analogous to ATP. ATP is the primary energy source, right? It's something like that. GTP or GDP also. So in the basal state, in the inactive state, the G protein is GDP bound. When it is active, the protein gets GTP bound. So when in this receptor, G protein coupled receptor, in the basal state is inactive, but when the signal, okay, the signal is also called first messenger. You can call acetylcholine first messenger, you can call insulin first messenger, adrenaline first messenger. The chemical signal is known as first messenger. Okay? When the signal binds to the receptor, the signal doesn't penetrate, right, pass through the membrane. It only binds to the receptor, and this receptor gets activated. When the receptor is activated, the G protein is activated. Okay? GTP bound, and then that initiates the signaling cascade, and that some of the molecules are known as second messenger because This is the first messenger, and the first messenger doesn't go through the membrane. It activates the proteins in the membrane, in turn releases the second messenger. The very concept, very discovery of a protein that is bound with GDP and GTP to be in the active state or inactive state got the Nobel Prize. The identification of a G protein got the Nobel Prize. Activation of the G protein releases the second messenger. That discovery also got the Nobel Prize. The structure of the G protein coupled receptor, 7 membrane structure, right? That also has a Nobel Prize. There's so many important discoveries in the basic sciences to understand the normal physiology that also helps to identify the molecular form. And this second messenger in turn continues the path. The good example of such second messenger is cyclic AMP. How many of you know cyclic AMP? Maybe too early one. Cyclic AMP, cyclic GMP, calcium is also second messenger. The point here is the first messenger is the hormone, other neurotransmitter, activates a cascade on the plasma membrane, releases messages inside the cell. That is the second message. Okay. Some of the second messengers are listed here. The important ones are cyclic AMP, IP3 also, and another important one is cyclic GP. Cyclic, we call them as cyclic nucleotides. Okay. These are the second messengers. These are downstream of G protein coupled receptors. Okay. We have seen what is ligand gated receptor, that is a channel. Okay. We have seen G protein coupled receptor. This receptor needs a G protein continuation of the pathway, that is second messenger dependent pathway. Third one is tyrosine kinase receptor. Okay. This is also again a receptor. It's a transmembrane receptor. It is inactive in the absence of a ligand or signal. All these receptors are inactive in the absence of a signal. When the signal is released, they bind to the receptors, they get activated. In this case, the receptor is an enzyme. And the enzyme is kinase. Very, very important physiological process in the body. Kinase is an enzyme. What the kinases do is they phosphorylate proteins. Extremely important step. The identification of phosphorylation also got a Nobel Prize. This is the third class of receptor, and many growth factors act on this receptor. Normal growth is very important. Abnormal growth is extremely dangerous. Good example for abnormal growth is cancer. Right? Cancer is nothing but uncontrolled growth. Many of the cancers are due to mutations in this tyrosine kinase receptor. So what we need? Drugs. The drugs we need to target these receptors. Either the receptors or the enzymes are active. That is tyrosine kinase receptor. Okay? I don't want to go through the details because many of you are very young in your minds to understand this. See, many of these cancers are related to the mutations in these tyrosine kinases. So many cancer types are associated with the abnormal tyrosine kinases. So the channel receptors, G protein coupled receptors, and the kinase receptors are extremely important for the chemical signals to propagate their signals and to mediate cellular responses. Okay? Clear? The last step in the signaling cascade, as I said, is protein phosphorylation. When the receptor is active, sometimes the receptor itself is a kinase. The penultimate step before a response, before proliferation, any physiological response. In any physiological response, proliferation, apoptosis, cell death, contraction, relaxation, secretion, you have protein phosphorylation. Extremely important step in physiological process. What is protein phosphorylation? and many of the second messengers also mediate the protein phosphorylation. Either calcium or the second messenger cyclic nucleotide, they in turn act through protein phosphorylation. What is protein phosphorylation? It's a phosphorylation of a protein, adding a phosphate group on a protein. Okay? And the enzyme that phosphorylates a protein is known as kinase. When the signal is protein is phosphorylated, we need to dephosphorylate also, okay? Because every signaling pathway has to be reversed. Otherwise, it will be abnormal signal. Every point it has to be reversed. So the phosphorylation is mediated by kinase. It's an addition of the phosphate group on specific residues on a protein. Okay, very specific residues. And the dephosphorylation is mediated by phosphatases. And the phosphorylation levels are highly regulated. I told you, right? Tyrosine kinase receptors, abnormal phosphorylation leads to many diseases. Good example is cancer. Abnormal tyrosine kinase activation, abnormal phosphorylation of protein. So tight regulation of phosphorylation is needed, and that is mediated by the kinases and phosphatases. If we have more phosphorylation, if we want to control the phosphorylation, what we need to do? For example, if we have protein that is phosphorylation levels tightly regulated, if it is more, we need to decrease it. What we can do? Dephosphorylate. That's also good. Okay, we can increase the phosphatase activity, right? So we can rapidly dephosphorylate. There are drugs that target, that activate the phosphatase actually. Other mechanism to decrease the phosphorylation is kinase inhibition, right? We can decrease the kinase. There are many drugs, many of the cancer drugs target this. When we have abnormal kinase, we have abnormal protein phosphorylation, abnormal growth. That is a hallmark of many cancers, abnormal phosphorylation. So the drugs that target kinases, the drugs that inhibit kinases can control phosphorylation and thus proliferation. So these processes are very tightly regulated. Okay? Extreme balance is important for physiological response. And many proteins are phosphorylated. It's an extremely simple process. It can change the activity, it can stabilize the protein, it does wonders in physiology. Okay? So tight regulation of phosphorylation is also needed. One of the hallmarks of signaling is amplification. So in every step, you have amplification of the signaling process. One signal activates many receptors. A single receptor can activate many G proteins, and one G protein can release many second messengers, and that cascade can increase. That is very important because the amount of chemical signal released is very tiny. For example, insulin or adrenaline, amount of chemical signal is very tiny, but we get a big response, right? So there is amplification in every step. That is also very important. That amplification is important. And the other important feature is transient nature. We don't need prolonged signaling. I just told you, if we have prolonged signaling of a kinase, what happens? Prolonged phosphorylation of proteins. Prolonged response. That is also abnormal. So every step, the receptor is activated and deactivated. The G protein is activated and inactivated. The second messengers are generated and they are degraded. Okay? Proteins are phosphorylated and dephosphorylated. At every level, there is very fine tuning of these cellular pathways. And if there is imbalance in the fine tuning, that will lead to abnormal signaling. What we call is disease. Right? Now we know what is a receptor. Okay? You know what is second messenger and the channels. Let us see what are the targets. What are the targets used in the medicine? The receptor is a protein that is present on the plasma membrane to receive the signal. If you want to activate the receptor, For example, if you want to amplify the signal, we can synthesize a chemical that looks like the signal and that can bind the receptor. They are very specific. Okay? So we can mimic a signal that I can activate a receptor. That is called an agonist in a pharmacological terms. Okay? For example, we can mimic a substance that is like acetylcholine. We can mimic a substance like adrenaline. We can mimic a substance like insulin. Or sometimes we can take the insulin also. That is an agonist. If we want, if the receptor is the problem, if we want to stop the receptor to be active, we have to block it. That is known as antagonist. So in the medicine, we use both agonists to stimulate the signal, okay, or we also use antagonists to block the signal. If there is more response, we block the receptor. I'll give a couple of examples. Okay. Acid secretion. We all know what is hyperacidity. Many of us know. Okay. Take large medicines. Sometimes, I don't know the generic names here. Fanta, right? Fanta, and Remidine or Cimetidine, right? Jantan. So these are the drugs we use for acid secretion. Let us see the physiology behind the acid secretion. Acid is released from specific cells known as acid secreting parietal cell. Acid is what? Hydrogen chloride. Okay. What happens? Again, acid secretion is a physiological response. It is regulated by the hormones or the chemical signals. In this case, it is regulated by the neurons, by the hormones, as well as by the parathyroids. Okay? This is a physiological response. When the food enters the stomach pH is very acidic, but when the food enters, it gets neutralized and the cells gets activated to receive the signals to produce a lot of acid. We need acid to partly digest the food. Okay? So acid secreting cells receives the neurocrine, endocrine, paracrine signals to release acid. And these signals act on a specific receptors known as histamine receptors. Histamine is a paracrine. So the main stimulant is histamine. That's a paracrine that acts on a receptor known as H2 receptor. Now we have plenty of H2 histamine acting on receptors. So what we need to suppress acid secretion? We need to block the receptor. Right? Agonists or antagonists? Antagonists. That's what exactly happens. Okay. The H2 blockers. Jantan, Remidine, Cimetidine, all these drugs block it. So when the receptor is blocked, you have acid secretion. That is one mechanism. Okay. Downstream of acid secretion also, here, if we go back, we also have other drugs, right? Like Fanta, Nexium, Travacin, I don't know the generic names here. Acid secretion also, the HCl secretion is mediated through a pump known as proton pump. Okay? Either you can block here at the level of receptor. When the receptor is activated, a proton pump is activated to release hydrogen ions. You can also block the proton pump. That is what the second generation drugs happen. Okay? They block the proton pump here. Either you can block the receptor or a proton pump. Again, insulin. I'll give one more example. Insulin secretion is by which cell? Pancreatic cells. What kind of cells? Beta cells. So when there is high glucose, when we eat carbohydrate food, carbohydrate is digested in the intestine, and the intestine sends a signal, okay, to the beta cells. And the signal is through hormones. And the hormones are known as GLP-1 and GLP-2. Glucagon-like factor, the name like that, okay, they are known as incretins. So the intestine, when it digests the carbohydrates, when the blood glucose level increases, the intestine sends the signals to the beta cells through these hormones known as GLP-1 and GLP-2. And these hormones act on specific receptors on the beta cell. Okay? They act on the receptors. Now there is insulin. So if you want to increase the insulin level, what do? What do you want to do? Block it or activate it? You want to activate them, right? You want more of these things. You want more insulin. That's what the wanted drug does. Ozempic. That's the latest drug, right? What Ozempic does, it mimics GLP-1 and GLP-2. It acts on the GLP-1 and GLP-2 receptors, which in turn causes insulin release. We can have other targets also, like insulin secretion is mediated by the channel. It's known as potassium ATP channels. Okay. When we block these potassium channels, there will be insulin secretion that depolarizes the cell, and there is insulin secretion. That's what exactly the glucose does. When there is increase in the blood glucose levels, glucose enters the beta cell, alters the ATP and ADP levels, changes the activity of the ATP channel, and causes insulin release. That is, if we block the ATP channel, there will be insulin release. So if you want to cause increase in insulin, what we need is to block that. There are drugs to block that also. Sulfonylurea, what the glucobeta or whatever that part, amyloparine, I don't know the drugs names, but the initial drugs that activate insulin secretion act on this ATP channels. Okay? Again, a channel is targeted. I'll give one more example for this. How second messengers kinases are very important. Muscle relaxation is mediated by a second messenger known as cyclic GLP in the smooth muscle. Okay. You all know the difference between the skeletal and smooth muscle. Smooth muscle is the blood vessels, gastrointestinal muscle, so penile muscles. These are all the smooth muscles. If you need muscle relaxation, we need cyclic nucleotide levels. And these cyclic nucleotide levels, as I said, are very tightly regulated. They are rapidly inactivated by enzymes known as phosphodiesterase. If you want to increase cyclic GLP levels, what we need, either we should activate this pathway, right, to produce it, or we should block this pathway. If we block this, this will remain high. For muscle relaxation, for hypertension, people is nitroglycerins. So they release cyclic GLP. Because muscle relaxation for hypertension, people use that. The wonder drug sildenafil acts here. Sildenafil is like what acts here. When this one is inhibited, what happens is cyclic GLP levels increases. When there is cyclic GLP level increases, muscle relaxation, penile muscle relaxation. Okay? So by altering the cyclic GLP production or degradation, we can increase or regulate muscle tone. I have many examples here with that that act on the receptors like beta blockers, metoprolol, propranolol. They are all act on the beta 1 receptors. The SSRIs that act on the serotonin receptors, growth factor receptors, insulin receptors, again metformin and Ozempic. Most of these drugs act on the receptor level and they regulate, they mediate or they rectify many of the abnormalities in cardiovascular diseases, psychiatric diseases, cancer drugs, okay, and diseases related to endocrinology also. Again, I have given a lot of examples here. Many of them act on the receptors and these are the diseases. Some of the drugs that act on the channels, I told you the receptors are channels. Many of the drugs that act on the sodium channels, epilepsy act on the, channels, epilepsy, hypertension. There are drugs that act on the calcium channels. Calcium is an important messenger that regulates blood contraction. Okay? If you want to regulate blood vessel contraction, you regulate calcium channels. Type 2 diabetes, I told you that that inhibits ATP channels, causes disease. There are drugs that target channels also. There are drugs that inhibit the kinases, particularly related to the cancer tyrosine kinase receptors, right? When there is abnormal high levels of this kinase activity, there is high phosphorylation levels of specific proteins that lead to abnormal growth. Many cancer drugs act on these receptors. Okay? These receptors, nothing but these are kinases also. So there are many drugs that act on this. Many of the kinases that are available, cancer drugs act on this. They inhibit. The cancer drugs they inhibit. There are drugs that activate the kinase. Insulin. It's a hormone, it's a drug that acts on this receptor that activates the kinase, corrects the diabetes. Metformin, that is also a diabetic drug that activates a specific kinase again, corrects the diabetes, and other drugs also. There are drugs that regulate phosphatase. We want to decrease the phosphatase. If we activate the phosphatase levels, there will be decrease. So, in the medicine, most of these drugs target specific, not specific, selective molecules to reduce the strength and the duration of normal signaling. Normal signaling is very strictly dependent on appropriate strength and appropriate duration. If there is abnormal strength, abnormal duration of chemical signals, that is a disease. And many of the drugs act on these signaling cascades. So signaling pathways is very important in the physiology. Abnormal signaling leads to diseases, and many of the drugs act on these selective molecules. Stop here. Any questions? Any questions from students? How do we take insulin? Oral or injection? One. You take some medicines orally, right? I want to answer from students. Why do we take? What is the necessary for taking insulin through the injection, not through oral, not through tablet? What is insulin? It's a protein, it's a peptide. What happens if you take a peptide? A lot of proteases. It gets inactive. I know you're not exposed to this kind of size yet. Yeah. Questions?
Do you have any questions? No? So in the absence of any questions, sir, we'll conclude this keynote address.
Thank you.
Please be seated, sir.
Oh, sure.
It's a small question.
Sure.
Nowadays, actually, the food is contaminated by the pesticides. Due to the accumulation of these low molecular weight substances in our cells, actually leading to the cancers. Actually, where do these low molecular weight substances are accumulating in the cells? How do they affect these cascade reactions?
I don't know how these pesticides are converted, processed inside the body, but many of them, I think most of these pesticides do lead to mutations. And many of these mutations that causes cancer are in the tyrosine kinase receptor. But I don't know how the mechanism by which these pesticides get converted in the body and what kind of byproducts cause these mutations. But net effect is causing mutations in the tyrosine kinase of the growth factors. That's a good question.
Any more questions? Sir, please visit. We are very fortunate to have Professor Kanam Srinivas sir, who has come all the way, taking pain from USA to Tirupati to here to address in the international conference. So sir has explained very well how the signaling, the role of signaling in the diseases. So disruption or misregulation of signaling is the basis of human diseases, the molecular basis of disease, how the diseases occur, what changes occur at the molecular level in diseases. So thank you sir very much, very kind of you, very nice of you sir. So the next felicitation program to our keynote speaker, please arrange. I request Department of Zoology to come on to this. Next invited talk is by Professor saisreelievevents sir from Indian Institute of Technology, Madras. Now, Dr. Swami sir will introduce our invited speaker.
Sir, please. I wanted to welcome you. Professor Rayala Suresh Kumar sir, please welcome sir. I wanted to introduce him, but there is a big profile is there, a 36-page profile is there, but I am going to introduce in a brief. Professor Rayala Suresh Kumar sir is a professor in Department of Biotechnology at IIT Madras with over 2 decades of research experience in cancer biology, molecular oncology and translational medicine. His research expertise in targeting oncogenes, development of small molecules and peptide inhibitors, mechanism of therapy resistance, CRISPR-Cas9 functional screening, tumor microenvironment studies, preclinical cancer models, and monoclonal and polyclonal antibody development for diagnosis of cancer. His academic research is actually rich, a lot of experience in teaching and research. He organized chairman also in GATE and JAM. Those are very competitive examinations nationwide, and he received many awards and honors. A fellow in National Academy of Science and National Bioscience Award. Those are very prestigious awards. Aligned with these 2 prestigious awards, there are many honors and awards received by the sir. With this very brief introduction, I welcome Suresh Kumar sir to give a talk to explore the biological wonders regarding this seminar. Thank you, sir. Please, sir.
Okay. First of all, thank you all for getting me here. It's a pleasure. So today, okay, I'm Suresh. I'm from professor in the Department of Biotechnology at IIT Madras. I was a trained cancer biologist for the last 25 years, and we work on molecules and molecular mechanisms, how normal cells get converted into cancer cells. Because once we know how normal cells gets converted into cancer cells, it is easy for us to target those cells. Like sir was telling, sir showed about signaling pathways, what are the ways that you inhibit, especially the growth factor, receptor tyrosine kinase signaling pathways, and there are monoclonal antibodies for it. So we also focus on identifying molecules that are responsible for conversion of normal cells, cancer cells allow the cells to get. You will find a way to stop them. So the whole focus of our lab is looking at those molecules and mechanisms. How do we look at them and stop them? So in the last 20 years, success on it. I would not say pure chastamo or we will not say that we are here, but incremental increase in understanding convert out so that somebody else can take a lead and do that. That's what we are here. And the other thing that we work is with animal models, cancer, all cancer animal models. We also work on patient samples, patient-derived explant models, and patient-derived xenograft models. So this is the recent trend. So I will show what are the hallmarks of cancer. First of all, 25 to 30 years back, ఎవరన్నా వచ్చి మన పక్కన క్యాన్సర్ అని చెప్పారు అంటే జనాలు అంతా భయపడిపోయేవాళ్ళు, పక్కన కూడా కూర్చునేవారు కాదు, ఏదో అందులో ఏమో అని చెప్పి. Now things have changed last 20 years or 25 years. Lot of things have changed because of extensive research on cancer. Cancer is not a contagious disease. Sleep, you do whatever you want, it won't spread from one person to another person. That's the first thing. Second thing, lot of improvement in therapeutics. ఇంతకుముందు క్యాన్సర్ వచ్చింది అంటే భయపడిపోయేవాళ్ళు, ఇప్పుడు అట్లీస్ట్ క్యాన్సర్ వచ్చింది అంటే వాట్ స్టేజ్ ఇట్ ఈస్ డయాగ్నైజ్ అని అడుగుతున్నారు. ఓకే, ఇట్ ఈస్ ఫస్ట్ స్టేజ్ కానీ, సెకండ్ స్టేజ్ కానీ, ఆర్ ఈవెన్ థర్డ్ స్టేజ్ ఫర్ సర్టెన్ టైప్స్ ఆఫ్ క్యాన్సర్. ఓకే, దేర్ ఈస్ ఏ మెథడాలజీ ఆర్ సస్టైన్ ట్రీట్మెంట్ మెథడాలజీ ఉంది కాబట్టి అంత భయపడాల్సిన పని లేదు. ట్రీట్మెంట్ ఈస్ లిటిల్ హార్ష్, but then at least patient will be able to survive. So that's what we call it as a overall 5-year survival period. So అది అటైన్ చేయొచ్చు. సో రీసెర్చ్ చేస్తే యూజ్ ఏంటి అని మీరు అడగొచ్చు. చేస్తున్నారు ఏం రాలేదు కదా సార్, 25 years గా చేస్తున్నారంటే అట్లీస్ట్ we could enlighten people with the knowledge that we took from this, saying that cancer treatment ఉంది, it can be cured provided it is diagnosed at an early stage and చెప్తాను. ఓకే, సో ఇనీషియల్ గా ఏదైనా యూ హ్యావ్ సమ్ ట్రబుల్, మనకి ఫర్ ఎగ్జాంపుల్ స్టమక్ పెయిన్ వచ్చింది అనుకోండి, ఏం చేస్తాము, ఒక డోలో వేసుకుంటాము, బామ్ వేసుకుంటాము, ఆర్ వాట్ ఎవర్ ద రెమెడీస్ దట్ వి డు. సెకండ్ టైం ఆల్సో విల్ డు, బట్ దీస్ ఆర్ ద స్మాల్ సింప్టమ్స్. మనం ఇగ్నోర్ చేస్తే ఈవెన్చువల్లీ ఓవర్ ఎ పీరియడ్ ఆఫ్ సర్చ్ యు హావ్ యాంటాసిడ్స్. మనం ఏం చేస్తాము, స్టమక్ పెయిన్ అంటే యాంటాసిడ్ వేసుకుంటాం. ఓకే, it subsides little for some time, but the tumor starts growing. So small symptoms that we ignore can eventually we have to pay a lot of price for it. So these are small symptoms that we ignore, and finally this could be a colorectal cancer or colon cancer or pancreatic cancer. The symptoms, see See, the most important problem is cancer starts with no pain, or you basically you don't realize the symptoms, and by the time it is diagnosed, especially pancreatic cancer, the patient is almost at the post stage. So diagnosis is more important than treating cancer. Initial stages to diagnosis, then treatment becomes easy. So in the 20-25 years back, only 3 options. First, surgery. The patient is fit for surgery, surgery chesi. ఎంతవరకు ట్యూమర్ తీసేయగలరో అంతవరకు తీసేస్తారు. Second thing, they go for chemotherapy, non-targeted chemotherapy. You give some drugs that kill the cancer cells and also normal cells. మీరు ఇప్పుడు సెల్ సైకిల్ ప్రోగ్రెషన్ చూసారంటే, సెల్ సైకిల్ ప్రోగ్రెషన్ చూస్తే G1, S, G2, M. These are the 4 different phases of cell cycle. And within this cell cycle, you have S phase, which is the DNA replication. So chemotherapeutic drugs, most of the chemotherapeutic drugs are anti-cancer drugs, work on S phase, which means that they work on damaging the DNA or they work on intercalating the DNA. Most of the drugs, okay, there are certain drugs that work on microtubules and platinum-based drugs, these are different ones, but most of them. That is, the whole concept of chemotherapy is based on damaging your DNA. When DNA extensively damage cheste emotundante, cells repair cheyalaka, cells will undergo apoptosis. This is the whole concept. Alage radiation therapy kuda is the same. You keep damaging your cellular DNA, damage chestund okatokadu kottaru, రెండోసారి కొడతారు, మూడోసారి కొడితే ఏమవుతారు, పడిపోతారు. So the same, the concept is cells. You keep damaging the DNA, the cell also will die. Okay, but the problem here is, it is not only the tumor cells, even the normal cells also go through the cell cycle, and then in the S phase they also get attacked with these drugs and then they also die. But the tumor cells cycle faster, so that is the reason more of the tumor cells will die when you compare with the normal cells, but still you have damage to the normal cells, and this is what is called the side effect that you create to the damaged cells. So he moved options surgery, chemotherapy, radiotherapy. Okay, he moved options to the therapeutic advantage kanna damage ekkundi. So first damage that you see valaki juttanta udipothundi, right? That is the first side effect that they have. Second thing, nausea, vomiting. Well, continuously they have nausea and vomiting because mostly proliferating cells, normal proliferating cells are present in the skin hair follicles. So epithelial cells of the skin hair follicles, normal cells could damage of them. Normal cells damage enough, you lose your hair. Okay, that is first one. Second thing, always everything in science has a reason. Second thing, nausea, vomiting in the question. Okay, when you take the drug, gastric epithelial cells are replaced faster than other cells because they have to retain in the extreme acidic environment. So our cells could have damage because of this. So that's why you have continuous nausea and vomiting. But these side effects are tolerable, then so that you basically tide over the chemotherapy and then do that. Okay. Last 10 to 20 years, I would say, last 15 to 20 years, chemotherapy, radiotherapy and surgery kaakunda, people have come up with, our physicians have come up with a new therapy called targeted therapy, like surgical monoclonal antibody therapy anochu. Okay, but then a drug first vachina kuda వాళ్ళ దేశానికే వస్తుంది, మన దేశానికి రాదు. ఓకే, ఎందుకంటే వాళ్ళ దగ్గర చాలా డబ్బులు ఉన్నాయి. ఓకే, సో ఇట్స్ నాట్ దట్ ద టెక్నాలజీ దే అడాప్ట్. ఓకే, or basically it's an advanced country and most people are, I would not say that they have a lot of money, but then the resources are more. ఇప్పుడు మనకి ఏదన్నా reagent ఏదన్నా కావాలి అంటే అక్కడి నుంచే రావాలి. సో అక్కడి నుంచి ఇక్కడికి వచ్చేసరికి అక్కడి నుంచి ఒక మనిషి ఇక్కడికి రావాలంటేనే 24 to 36 hours అవుతుంది. So reagent takes a lot of time, but for them వాళ్ళు పొద్దున ఆర్డర్ చేస్తే సాయంత్రం మధ్యాహ్నానికి వచ్చేస్తుంది. It is not that, and they are also more motivated because our population is more, number of the population is more, we don't. We are basically a developed country. I will never say we are a developing country. India is a developing country. We are a developed country, but they are an advanced developed country. So, sorry sir, I am not trying to. So, they have much more resources. Research with the amount of money that they spend is not. So, first thing, there is one antibody called 𝕼𝕼, like 𝕼𝕼 receptor antigen cancer. 𝕼𝕼 is used to treat HER2 positive breast cancers. Okay, in HER2 positive అనేది is expressed only 13 to 15% of the breast cancer, but still the antibody was working very good. our country, there's one company called Genetic who started making this antibody. This antibody was costing them $3,000 to $5,000 per dose. And Indian rupees it is close to 5 lakhs now. Okay, but then they have a different insurance setup and all that, so insurance pays for them. They could afford to do that, and it is controlled or it is maintained by a patent right. So nobody in the country could get it except that because it's made by a US company. Fine, okay. At least we know that from the data, whatever that they are getting it, Herceptin is working very good for HER2-positive breast cancer. If people or somebody is diagnosed with HER2-positive breast cancer, they will not die for next 15 to 20 years, which means that there is a lot of improvement. Manishi, 50 years or 40 years of diagnosis, 60 to 70 years he can live safely. This is only the average time I am telling you. He can live more than that. So this is a monoclonal antibody. This is called the 4th level of targeted therapy, and the side effects are 99% less than the chemotherapy, because it goes and binds to the receptors that are overexpressed on those cancer cells or those. So even though research just something will come out, it takes a lot of time. So the drug market minimum of 10 to 15 years of research is required. Ala vachina drugs kuda oka 100 drugs clinical trials lo vaste 95% of drugs they fail in clinical trials. ఆ 5% లో కూడా if they come to the మార్కెట్ నుంచి విత్డ్రా చేసే డ్రగ్స్ రెండో కూడా ఉంటాయి. మార్కెట్కి వెళ్ళి 5 years 10 years డేటా వచ్చిన తర్వాత ఓకే ఇది ఉన్న డ్రగ్స్ కన్నా సరిగా పనిచేయట్లేదనో ఆర్ దేర్ వర్ అదర్ ప్రాబ్లమ్స్, అందుకే ఇప్పుడు ఏమంటున్నారంటే రీపర్పసింగ్ ఆఫ్ ద డ్రగ్ అంటున్నారు. ఓకే, కడుపులో పనిచేసే డ్రగ్ తలనొప్పి కూడా పనిచేస్తుంది, ఆర్ diabetes పనిచేసే డ్రగ్. Diabetes the best medicine is metformin, సార్ చెప్పారు. Metformin now they say it also works for cancer. అదే మరి అప్పుడు ఎందుకు చేయలేదు? when you looked at for diabetes, నువ్వు డయాబెటీస్ ఒకటే చూసావు కాబట్టి you didn't realize the other side. So these are the problems if you don't look at other parts. ఒక డ్రగ్ సెల్ లో ఇచ్చాము అంటే or you give it to a human body, we cannot go inside లోపలికి వెళ్ళి సెల్ లోపలికి వెళ్ళి ఏమి చూడలేము. ఏం చూస్తాం మనం అంటే ఎండ్ పాయింట్ ఎస్ఎస్ బట్టి, ఆ ఎస్ఎస్ బట్టి ఇప్పుడు యు ఆర్ లుకింగ్ ఫర్ డయాబెటీస్ అంటే షుగర్ లెవెల్స్ ఎంత ఉంది తీసుకున్న తర్వాత ఎస్ఎస్ఏ చూస్తాం తప్ప మిగిలిన సైడ్ ఎఫెక్ట్స్ ఏమీ చూడడం. సో దీస్ ఆర్ ద ప్రాబ్లమ్స్ అంటే. సో ఈ ప్రాబ్లమ్స్ వల్ల 10 years తర్వాత రివర్ట్ చేసిన బ్యాక్ కాల్ చేసిన డ్రగ్స్ కూడా. సో డ్రగ్ డిస్కవరీ అనేది ఒక యజ్ఞం లాగా చేస్తారు. ఒక 10-15 years చేస్తే ఒక డ్రగ్ బయటకు వస్తుంది, which basically will have a lot of, like Alani sir, 𝕃𝕀𝕍𝔼 going to happen. There's one BCR-ABL inhibitor, 𝕃𝕀𝕍, which was a wonderful drug that they have made it. First few years it works very nicely, but then ఇప్పుడు ఏం చేశారు, వాడంగా రెసిస్టెన్స్ వస్తుంది. సో ఆ డ్రగ్ యూజ్ లేకుండా పోతుంది after few years. So lot of inherent problems that could eventually lead to a backfall, but still over the last 50 years మనము క్యాన్సర్ భయపడే స్టేజ్ నుంచి లేదు క్యాన్సర్ వచ్చినా కూడా ఏమీ అవ్వదు, there are ways to treatment అనే స్టేజ్ వచ్చి. Okay, fourth modality of treatment is monoclonal antibody therapy, which is good, but అన్ని క్యాన్సర్స్ కి monoclonal antibodies therapy. Now next modality of therapy మళ్ళీ వాళ్ళ దేశంలోనే ఉంది, మన దగ్గరికి రాలేదు ఇంకా, is precision therapy. ఒక ఊర్లో ఒక ఫ్యామిలీలో ఒకటే ఫ్యామిలీలో ఇద్దరు పేషెంట్స్ హ్యావింగ్ ద సేమ్ టైప్ ఆఫ్ క్యాన్సర్ అనుకోండి, ఆ ఇద్దరు పేషెంట్స్ ట్రీట్మెంట్ కి సేమ్ గా రెస్పాండ్ అవ్వదు. బికాస్ ట్యూమర్ సెల్స్ ఆర్ వెరీ హెట్రోజినస్. ఈయన ఉన్న ట్యూమర్ కి సెల్స్ సేమ్ గా బిహేవ్ చేయదు. సో ద సేమ్ డ్రగ్ దట్ యు గివ్ టు దెమ్ విల్ నాట్ వర్క్ ఈక్వల్లీ టు బోత్ ద పేషెంట్స్. అప్పుడు ఏం చేస్తారంటే ఆ పేషెంట్ నుంచి టిష్యూ తీసుకొని either they do the whole genotyping, genetic profile తీసుకొని they do all the markers అన్ని చేసి what genes are upregulated, what genes are not regulated అలా చేసి ఆ ట్యూమర్ టిష్యూని మౌస్ లో వేసి ఏ డ్రగ్స్ వర్క్ అవుతుంది అని పర్టికులర్ గా చెక్ చేసి విత్ ఇన్ a month time they will know to which drug it responds. Okay, but దీనికి వాళ్ళు ఎంత స్పెండ్ చేస్తారంటే నెబ్రోజ్కి క్లోజ్ టు $40,000-50,000 స్పెండ్ చేస్తారు. ఓకే, బట్ దెన్ ఇట్ ఈస్ వర్త్ ఎందుకు అంటే అదే పేషెంట్ ని ఓకే దెర్ ఆర్ మొత్తం అంతా వరల్డ్ లో తీసుకుంటే హార్డ్లీ 30-40 drugs are there to treat all types of cancers. ఇంతకన్నా ఏమీ లేదు. So medical oncologist or a treating physician ఏం చేస్తారంటే he uses a combination of the drugs. The trick of a medical oncologist, ఇప్పుడు వీళ్ళు ఈ దగ్గరికి వెళ్తాం, సారీ ఈ దగ్గరికి వెళ్తాం ఈ డాక్టర్ దగ్గరికి, నాకు ఫస్ట్ ఒపీనియన్ ఏం సరిగ్గా చేయలేదు, సెకండ్ ఒపీనియన్ ఇంకోటి థర్డ్ ఒపీనియన్. See, the medical oncologist will not do anything. Only thing his skill lies in detecting or guessing which sort of combination works. But ఇప్పుడు ఆ రిస్క్ కూడా తీసుకోవట్లేదు. They take the sample, do PDX, VDA models and then genetic genomic profiling and all that, and then they come up with the marker senses. Okay, ఈ combination of the drug works for this అని చెప్పి 1 month లో based on the reports that you can see, but ఈ ప్రొఫైల్ అంతా కావడానికి they will spend $40,000 to $50,000. మా దగ్గర $40,000 to $50,000 ఉంటే నేను ఇక్కడికి వచ్చేందుకు ఇవన్నీ చేసుకుంటాము కదా. So we don't even need to work. Okay, so but then their insurance takes care of that. So that technology has come. This is called the tailored to the needs of the individual. So precision therapy. ఆ పేషెంట్ కి ఈ డ్రగ్ ఆర్ ఈ కాంబినేషన్ వర్క్ చేస్తుంది అని చెప్పి స్టార్ట్ చేశారు. సో ఇప్పుడు దట్ హస్ బికమ్ ఏ ట్రెండ్. అది పీపుల్ ఆర్ ఫాలోయింగ్ ఇట్. అక్కడి నుంచి మన వాళ్ళ అదర్ కంట్రీస్ కంపేర్డ్ టు US, okay, if it is drug or some therapy has to come here, it takes a minimum of 10 to 15 years to us. మనం కూడా స్లోగా మన స్టాండర్డ్ ఆఫ్ లివింగ్ కూడా పెరుగుతుంది. సో పీపుల్ ఆర్ ఏబుల్ టు అఫోర్డ్, దే ఆర్ గోయింగ్ ఫర్ ఇన్సూరెన్సెస్ అండ్ హాస్పిటల్స్ ఆర్ ఆల్సో trying to see the best treatment that they could give. But what the bottom line is, over the last 50 years, cancer treatment has taken a different strategy. Okay, chemotherapy means we have come all the way to precision therapy, and it is going in a good direction. The ముందు ఏంటంటే chemotherapy అంటే just regular radiotherapy, linac కట్టేసి gamma radiation chalo. Now we have all gone linac or regular gamma radiation common. People are going for proton therapy also. Proton therapy is the most advanced therapy that they are giving. But for some different tumors they have to give, where deep-seated tumors loki the radiation penetrate out. The proton therapy is the best one, which costs approximately now 20 to 25 lakhs of per treatment. But then doctors, it is being misused. Okay, proton therapy one chapter. But then proton therapy is another advanced therapy in radiation therapy. So if we look at 20-30 years back, we are in a far better shape when it comes to cancer treatment. Okay, ఇవన్నీ ఎలా వచ్చాయి అంటే monoclonal antibodies కానీ precision therapy కానీ small molecule inhibitors, especially receptor tyrosine kinase, సార్ చెప్పారు ఒక చిన్న మాలిక్యూల్, స్మాల్ మాలిక్యూల్, కెమిస్ట్రీ పీపుల్ లో స్మాల్ మాలిక్యూల్ ఇన్హిబిటర్, అదొక డ్రగ్ రోజు ఒక పిల్ తీసుకుంటే యువర్ EGFR induced cancer, which is head and neck cancer or breast cancer, will be treated. Okay, at least it will be in control. So దీనిలో సైడ్ ఎఫెక్ట్స్ లో స్మాల్ మాలిక్యూల్ ఇన్హిబిటర్స్, యాంటీబాడీస్, నౌ bispecific antibodies, lot of things have improved and people are in the clinic అంటే హాస్పిటల్ ట్రీట్మెంట్ వచ్చింది అంటే పేషెంట్ is getting. So over the last 50 years, I would say cancer research has done extensive advantage or given extensive advantage to the patients beyond doubt. So that was why people have to study, come to research, do the research and all that. So దీనివల్ల ఉపయోగాలే ఉన్నాయి తప్ప there are no adverse effects. Okay, now ఇప్పుడు ఈ ట్రీట్మెంట్ స్ట్రాటజీస్ అన్ని వచ్చాయి అంటే ఇవన్నీ ఎలా వర్క్ చేస్తున్నాయి, దేని మీద వర్క్ చేస్తున్నాయి, టార్గెట్స్ అన్ని ఎలా అంటే we just see cancer. If you take a cancer cell, అదేదో మీ జంక్షన్ లో ఉన్న సిగ్నల్ పాత్వే లాగా ఉంది. ఓకే, ఇన్ని సిగ్నల్ పాత్వేస్ యాక్టివేట్ అయితే దేని అని చెప్పి నేను టార్గెట్ చేస్తాను. ఎవరైనా ఏ డాక్టర్ అయినా ఏం చేస్తాడు, ఎంతో చూడండి, చూడడానికి కళ్ళు తిరుగుతున్నాయి. ఓకే, దిస్ ఇస్ ఓన్లీ నోన్ పాత్వేస్. ఇంకా తెలియని పాత్వేస్ ఎన్ని ఉన్నాయో తెలియదు. క్యాన్సర్ సిగ్నలింగ్ ఇస్ సో కాంప్లెక్స్. ఓకే, ఎలా ఇన్ని రోజుల నుంచి రీసెర్చ్ చేస్తున్నారు, ఇన్ని డబ్బులు దప్పుకుంటున్నారు, దట్టుకుంటున్నారు, ట్రీట్మెంట్ సరిగా అంటే ఇంత ట్రీట్మెంట్ చేస్తున్నారు, ఇంకా క్యాన్సర్ ఉంది కదా అంటే ఏం చేయాలి? ఓకే, మీరు అయాన్ ఛానల్ పాత్వేస్ బ్లాక్ చేస్తే రిసెప్టర్ టైరోసిన్ పాత్వే యాక్టివేట్ అవుతుంది, దాన్ని బ్లాక్ చేస్తే ఇంటిగ్రిన్ పాత్వే యాక్టివేట్ అవుతుంది, దాన్ని పాజిటివ్ ఏది చేస్తే ఏది అవుతుందో ఇది చూస్తే తెలుస్తుంది. నాకు ఆ సెల్ లో పోయి నేను చూడలేనే, ఓన్లీ ద ఎండ్ పాయింట్ యూ కెన్ సీ. సో మనం ఏం చేస్తాము, రిసెప్టర్ టైరోసిన్ కైనేస్ బ్లాక్ చేసి ఓకే అది బ్లాక్ అయిపోయింది సార్ అని చెప్పి మనం పక్కకి వెళ్ళి కూర్చుంటే పక్కన ఇంకో సిగ్నలింగ్ పాత్వే యాక్టివ్ అవుతుంది. సి ఇప్పుడు మీకు ఒకసారి క్లాస్కి రావాలి, రాలేదు, ఇంకొకసారి ఆఫ్ చెప్పి వెళ్తారు, ఓకే నాకు నేను లేదు తీసుకో అని చెప్పి అట్లనే ఒక పాత్వే పని చేయకపోతే పక్కన వచ్చి ఈజ్ వర్కింగ్ ఫర్ దట్ ఫెలో. So basically you are lost because cancer signaling is so complex that nobody knows how the signaling crosstalk works. Okay, itla block cheyadam modalu pedte it work avutundi, it compensate ikkada cheste ikkada అందుకే last 15 years or 10 years lo cancer is not treated with single drug. మీరు ఎక్కడన్నా చూడండి chemotherapy ఒక డ్రగ్ ఇచ్చి chemotherapy చేయట్లేదు. They always use a combination of 2 to 3 drugs which target different pathways, and the effects are more. The only thing that the doctor takes into account is the toxicity because of this combination is not high. That we will ensure. Other than medical oncologist and surgical oncologist, but always given us a combination therapy of 2 to 3 drugs, which is much more effective than a single one. Single one చేసుకుంటే ఒక 6 weeks single one చేస్తే ఓకే ఇది వర్క్ అవ్వలేదు, మళ్ళీ నెక్స్ట్ వన్ పోతాడు. ఇట్లా ఈ పుణ్యకాలం అంతా పోతే పేషెంట్ విల్ బేసికలీ హ్యావ్ starting primary tumor నుంచి secondary or metastasis అవుతుంది. So these are the problems. So it is so complex signaling pathway, madam. It is difficult to target or identify which one is. Okay, madam, cover. Good. Yeah. So cancer is a large group of disease that can start almost in any organ or tissue of the body when abnormal cells grow uncontrolled. It tells cancer and identity. Okay, normal cells fast గా divide అయ్యి ఎక్కువ cells అవుతాయి or abnormal cells, which is not the only thing that happens in cancer. There is lot of background information how these normal cells cancer cells అవడానికి మీ tumor suppressor genes కానీ oncogenes కానీ very important. Tumor suppressor, if we are normal అంటే మన tumor suppressor genes are functioning properly. The most important example of tumor suppressor gene is P53. Okay, P53 నార్మల్ గా ఉంటుంది, దాని పని దాన్ని చేసుకొని ఇస్తే మనం ఓకే దాన్ని చేసుకొని పిజ్జా తింటాము, బర్గర్ తింటాము, అండ్ ఎక్కడ వెళ్ళొద్దురా అంటే ట్రెక్కింగ్ అని ఎండకి వెళ్ళిపోతాము. ఓకే, హై ఆల్టిట్యూడ్కి వెళ్తాము. ఓకే, సోల్జర్ అంటే హై ఆల్టిట్యూడ్ తప్పక వెళ్తాడు బికాస్ హి హస్ టు సేవ్. మనకి ఏం పని, ద మోర్ యు గో హై ఆల్టిట్యూడ్ యు గెట్ మోర్ ఎక్స్పోజ్ టు రేడియేషన్. లేకపోతే ఫ్రెండ్ తోటి వాడు ఎక్స్రేకి వెళ్తే వాడు తోక మనం, ఓకే ఎంఆర్ఐకి వెళ్తే వాడికి తోక పోనీ అక్కడ కూర్చొని లేదు వాడు నా క్లోజ్ ఫ్రెండ్ అని చెప్పి లోపలికి వెళ్తాం. ఏమవుతుంది, ఆల్ ఎక్స్రేస్ నార్మల్ డయాగ్నోస్టిక్ ఎక్స్రేస్ ఆర్ నాట్ వెరీ డేంజరస్, బట్ దెన్ వెన్ ఇట్ కమ్స్ టు రిపీటెడ్ ఎక్స్పోజర్ యూ డ్యామేజ్ యువర్ డిఎన్ఏ. ఈ డిఎన్ఏ డ్యామేజ్ నార్మల్ గా మన హ్యూమన్ బీయింగ్స్ ఆర్ సో ఎఫిషియెంట్, ద మెషినరీ సో ఎఫిషియెంట్, డ్యామేజ్ అయితే ఇమ్మీడియట్ గా రిపేర్ చేస్తారు. ఓకే, ఎన్నిసార్లు ఎంత ఒక 1 into 10 to the power of 18 టైమ్స్ లో ఒక్కసారి ఒక మ్యూటేషన్ వస్తుంది. అంటే ఇమాజిన్ చేయండి ఎన్ని నెంబర్లు ఉన్నాయో, అయినా కూడా మనము అంత ఎక్స్పోజర్ చేసుకొని వీఆర్ గెటింగ్ మ్యూటేషన్స్. ఓకే, P53 దాని పని దాన్ని చేసుకొని అదేం చేస్తుంది, మనకి ప్రశాంతంగా ఉంచుతుంది ట్యూమర్స్ కాకుండా. మనమేం చేస్తాం, వాటిని ఊరికే ఉండని అటెళ్ళి ఇటెళ్ళి ఏదో ఒక డామేజ్ చేసి వాటిని మ్యూటేట్ చేస్తాం. If P53 gets mutated, okay, it will never function as a tumor suppressor, which means that your body lost one of the important tumor suppressor function. Okay, if P53 is mutated, is mutated in almost all 80% of the tumors. Okay, so 80% of the tumors is P53 mutation. When P53 is mutated, it will not function as a tumor suppressor gene. In turn, what happens is that there are certain proto-oncogenes that get activated to oncogenes. Proto-oncogenes are nothing but normal levels of VEGFR, normal levels of HER2. All these are proto-oncogenes which are required for your regular signal transduction pathway. Cell signal transduction membrane nunchi nucleus ki vachi signal transcription translation activate chesi మీ డే టు డే ఫంక్షన్స్ కి ప్రోటీన్స్ కావాలి కాబట్టి అది చేసేది నార్మల్ సిగ్నల్ ట్రాన్సాక్షన్. When you have overexpression of these receptors or mutation in these receptors, then cells behave differently and they basically lead to tumorigenesis. So these properties, okay, when abnormal cells go uncontrolled, go beyond these usual boundaries to invade adjoining parts of the body or spread to other organs. So cancer cells are not మనకున్న బిహేవియర్ బట్టి మన మెంటాలిటీ బట్టి ఇప్పుడు మనకి ఏంటి వరంగల్లో ఒక ఇల్లు ఉందంటే వీ డోంట్ స్టే విత్ వన్ ఒక ఇల్లు ఉంది చాలు అట్లా ఉంటాం. పక్కన హన్మకొండలోకి ఇల్లు కావాలి, కరీంనగర్లోకి ఇల్లు కావాలి ఇట్లా. సో క్యాన్సర్ సెల్స్ ఆర్ ఆల్సో సో గ్రీడీ, ఒక చోట స్టార్ట్ అయితే అక్కడ ఉండవు. ఓకే, ఇప్పుడు ఏం చేస్తారంటే ఇక్కడి నుంచి పక్కన ఇంటికి వెళ్తాడు, పక్క ఆర్గానికి వెళ్తాడు. ఓకే, పక్క ఆర్గానికి వెళ్ళినా కూడా వాడు పక్కన ఉన్న దాని దగ్గరికి వెళ్ళాడు. ఎక్కడ కంఫర్టబుల్ గా ఉంటే అక్కడికే వెళ్తాడు. మనకు కూడా ఒక ఇక్కడ నుంచి పోయి పల్లెటూరులో ఇల్లు కట్టుకోం కదా. వి గో టు ఎ ప్లేస్ వేర్ మార్కెట్ ఉందా, మళ్ళీ రియల్ ఎస్టేట్ లో నెక్స్ట్ 10 years అది ఇంక్రీజ్ అవుతుంది. దిస్ ఫెలో ఆల్సో గోస్ అండ్ సీక్స్ ఫస్ట్ ఇన్ ద లంగ్స్. ఎందుకంటే ఈజీగా ఆక్సిజన్ దొరుకుతుంది, బ్లడ్ సప్లై దొరుకుతుంది, హ్యాపీగా ఉండొచ్చు. సాఫ్ట్ టిష్యూ ఇన్వైట్ చేసేదానికి lungs, liver, you have to the bone. So it also preferentially goes to certain organs where it can get easy access to measure the glucose kavali, cells provided, oxygen kavali, oxygen kavali, blood supply kavali. Blood supply also, meeku soft tissues kelte it can easily invade the existing blood vessel. This is called angiogenesis or neoangiogenesis. Pakku blood vessel nunchi oka pipe vestukuntadu, manam pakkana inti nunchi oka pipe water vestukunte vaati adakundane vestukuntadu, manam ala chestam. So all these properties, basically these properties are the ones that make cancer cells more and more aggressive. Okay, as long as primary tumor start ayindi, head and neck or throat or mouth lo start ayindi, akkade unte it becomes more easy for anybody or medical oncologist to treat. Localized ga unte treat cheyochu. So ee staging anta stage 1, stage 2, stage 3, stage 4 is all dependent on tumor. Primary unte it is always the first stage or second stage max. Okay, depending on the type or size of the tumor. Second stage or third stage is depends on where it has migrated. Pakkana lungs velinda, liver velinda, sometimes to the brain or sometimes to bone marrow. These are the most important sites. So is staging. So these are basically the reason why they move from one place to another. It is survival. Ikkada ayipoyindi. Okay, I am anyway settling here. So it also goes to other places because it wants to expand its college. This is called the metastatic cascade. There is a whole phenomena regarding metastatic cascade. So finally, మొత్తం అంతా స్ప్రెడ్ అయిపోయింది బాడీ. సో దిస్ ఇస్ కాల్డ్ మెటాస్. యాజ్ లాంగ్ యాజ్ ద ట్యూమర్ ఇస్ ఎట్ ద ప్రైమరీ సైట్ ఎక్కడ స్టార్ట్ అయింది అప్పుడు ఉన్నప్పుడు డయాగ్నోస్ చేస్తే పేషెంట్ ఈజ్ సేఫ్. ఓకే, 90% ఈజ్ సేఫ్. అంటే హీ హస్ టు బి ట్రీటెడ్, బట్ డెఫినెట్లీ వన్స్ ద ట్రీట్మెంట్ స్టాప్స్ అండ్ కంటిన్యూస్ ఫాలో అప్ అయితే 5 years కంటిన్యూస్ గా ఫాలో అప్ చేసి దెన్ ఇఫ్ ఇట్ గోస్ బియాండ్ దట్ పేషెంట్ ఈజ్ సేఫ్. బట్ అది మనం చేయము. ప్రైమరీలో ఎక్కడైనా ఇక్కడ చిన్నది అయిందంటే పక్కన ఏమవుతుంది పసుపు పెడతాము, మాక్సిమం పసుపు పెడతాము, లేదంటే డోలో లాగా డోలో తినేస్తాము. ఆర్ సమ్ టైమ్ ఇన్ఫ్లమేషన్ ఏమవుతుందంటే డోలో తిని కొంచెం కంట్రోల్ అవుతుంది, బట్ ఇన్సైడ్ ఇట్. సో యూఆర్ బేసికలీ మేకింగ్ ఏ acute inflammation to a chronic inflammation. So persistent inflammation. So inflammation is one important reason that could potentially trigger. And any inflammations to cancer avutundi ani kaadu, but that could be one of the reasons that could trigger cancer. So don't ignore the inflammations. So ivanni manaki evaru cheppali, ippudu nenante meeku cheppanu, naaku kuda evaru cheppuntaru. So all these properties next level. ఇవన్నీ క్యాన్సర్ సెల్స్, నార్మల్ సెల్స్ క్యాన్సర్ సెల్స్ అవుతాయన్నది ఈ ప్రాపర్టీస్ ఉంటే ఇవి క్యాన్సర్ సెల్స్, ఇవి లేకపోతే ఇవి నార్మల్ సెల్స్. బికాస్ ఒక నార్మల్ పేషెంట్ తీసుకొచ్చి మీరు క్యాన్సర్ అనండి ఆ భయంతో సస్తాడు సైకలాజికల్, రైట్? సో ద మోస్ట్ డేంజరస్ థింగ్ ఈస్ డయాగ్నోసిస్ షుడ్ బి అక్యురేట్. ఓకే, ఇంతకుముందు ఒక ఎలిఫెంట్ స్టోరీ ఒకటి చెప్పాలి. ఒక బ్లైండ్ మ్యాన్ కి ఎలిఫెంట్ దగ్గర తీసుకెళ్ళి తోక పట్టుకో, ట్రంక్ పట్టుకో, ఇది పట్టుకో, ఇది పట్టుకో అంటే he says different things. I know, I'm sure you know the story, right? Blind and an elephant. Likewise, cancer diagnosis is more important for the therapy or for controlling it rather than anything else. ఎందుకంటే నార్మల్ ఇండివిజువల్ నార్మల్ గా ఉన్నోడిని, బికాస్ the medical oncologist or the radiologist is not there. One cancer and 50% his mental status will be psychologically will be there. Okay, so it is very important for an acute cancer diagnosis or accurate cancer diagnosis before you tell him that he is a cancer patient. Avanni enti ante ee properties telusukuntene then he will be able to do the correct justice. Okay, so sustained proliferative signaling, cancer cells will always have continuous proliferative signaling because your receptor tyrosine kinases are activated. Search your receptor tyrosine kinase and GPCR signaling. So cancer cells are continuously proliferative signaling. General ga proliferative signaling cells eppud divide avvali meru puttagane mimmalni toddler antaru. Okay, toddler antaru. Meru toddler nunchi old or adult వచ్చినంత వరకు మీరు గ్రో అవుతా ఉంటారు. ఒక స్టేజ్ వచ్చిన తర్వాత గ్రోత్ ఉంటుంది, ఏమి ఉండదు. సో డ్యూరింగ్ ఎంబ్రియానిక్ డెవలప్మెంట్ అండ్ when your growth and differentiation stage, development stage, you need cells to grow. ఆ cells కూడా they cannot grow on their own. Growth factors comes and binds to the receptors and then it starts
growing. So E process, normal cells will have a control of the growth. That is why you have cell cycling dependent kinases and inhibitors. So these cycling dependent kinases basically helps in proliferation of these. Okay. They help in proliferation of the cells, as well as you also have inhibitors. Okay. E balance unte, okay, then you don't have a problem. But cancer cells property ended with evero avasram ledu. Okay. If a guy Raj kanna mundu double ledu, okay, so if that fellow thinks that I have to grow, it starts growing. That is what is called sustained proliferative signaling. Irrespective of any growth factor signaling, it starts growing. So this is one important property of cancer. Enduku avutundi ante they try to grab signals from the other cells or the neighboring cells which are the normal cells, and then they start proliferating. This is not good for the cell. So sustained proliferating signaling is the first hallmark of cancer cells. If somebody sees that the cells are sustained proliferation without any growth signals, you can consider them as a cancer cell. Ee property teliste manaki okay, ee growth signaling ekkadi nunchi vastundi ani cheppi you can find inhibitor or something. So always understanding the molecular mechanism and the pathway will help you to. Ippudu man inside you, I take the watch and throw this side. I cannot go and set that side, right? And I think that dorkutunda. So your drug or targeting pathway should be very specific. Okay, I know this is what is leading to sustained pathways, proliferation pathway. I look at what are the signaling pathways. I try to. Alane, receptin gani, ELISA gani, C225, all these monoclonal antibodies for EGFR and receptin, small molecule inhibitors, they came into place, and they are doing very good in the clinic. Okay, leave about resistance, whatever that they do. The other problem is EGFR inhibitors. So head and neck cancer, lung cancer, work chesante efficient in other cancer types work out because the targets are not exposed. But anyway, so at least they are trying to treat the other ones. So okay, I think I'm overshooting.
This is technical problem.
So the second thing, like I said, sustained proliferative signaling, and second thing is insensitivity to growth factors. Like మనం ఏం చేస్తాం, మన P53 అని కూర్చోరాని కొన్ని చేయకొని కూర్చోని చెప్పి కూర్చోరు. So mutations in P53. So anti-growth signals are when a cell is about to proliferate more, your P53 is called a guardian of the genome. So మన parents మనకి ఎంత advantage or ఎంత support చేస్తారో, P53 supports your cells like that. So if there is no P53, you cannot imagine any much. It acts as a DNA repair pathway, it is a stress response pathway, everything that it helps. దాన్ని మనం అన్నికైతే కూర్చోరాలి. Okay. So that fellow will sit quiet and with the mutation. So you don't have sustained your insensitivity to growth signals is lost, and basically your cells again start proliferating. P53 control like you don't have it. That is the second one, insensitivity to anti-growth signal. Third one, angiogenesis or neoangiogenesis. Cancer cells start making their own blood vessels from the adjacent blood vessels, and then they start drawing blood. ఎందుకంటే మనిషి సర్వైవల్ కి గ్లూకోజ్ కావాలి. ఆ గ్లూకోజ్ కావాలి అంటే బ్లడ్ సప్లై కావాలి. క్యాన్సర్ సెల్స్ ఇక్కడి నుంచి అక్కడికి వెళ్తే మన ఒక చోట నుంచి ఇంకో చోటుకి వెళ్తే పాలవాడు ఉన్నాడా, వాడు ఉన్నాడా, వీడు ఉన్నాడా, సర్వేడు ఉన్నాడు చూసుకునేట్టు వీడు ఎవరిని అడగడు. ఆ పక్కన ఉన్న టిష్యూస్ నుంచి he draws the blood, and that is how he gets the glucose. So angiogenesis. Fourth one, metastasis and invasion. ఒక చోటు నుంచి he will go to a place, other place, and then it tries to settle by invading the different organs. You need lot of biology to invade the different organs. It has to degrade matrix metalloproteases, it has to have integrins, it has to have all these ones. But still, they sustain by going and settling at other places, which are the different organs, lungs, relatively lungs or liver. So fourth one. Fifth one is this one, telomerase activity site. ఒక cell, every person, మీకు 100 కన్నా ఎక్కువ బతకాలని ఎవరికి ఉంది? ఉన్నారా? ఎందుకురా బాబు, 50 ఏళ్ళు వస్తేనే అన్ని సరిగ్గా తింటే ఎసిడిటీ, కొంచెం ఎక్కువ తింటే ఎసిడిటీ వస్తుంది. షుగర్, కొంచెం షుగర్ స్వీట్ ఏదైనా తింటే షుగర్ ఉంది, డయాబెటీస్ ఉంది. ఓకే, ఉప్పు ఎక్కువ తింటే బీపీ ఉంది. గట్టిగా వచ్చేస్తే చచ్చిపోతాం. ఓకే, సో nobody wants to live at a older age is much more difficult. So likewise, any cell that is born has to die. Okay, so that is the cell theory that was proposed when 𝕃𝕀𝕍𝔼, Sleeden and Schwann cell theory. Every cell comes from a pre-existing cell. Any cell that is born has to die, and the structural and fundamental unit of any living being is the cell. ఓకే ఒకతను ఒక సపోజ్ గై ఈజ్ స్లీపింగ్ వాడు ఉన్నాడా లేడా అనేది ఎలా చెప్తారు ఈ స్లీపింగ్ సైలెంట్లీ ఒక్కోసారి మనకి డౌట్ వస్తుంది వీడు ఉన్నాడా పోయినాడా సో హౌ డు యు డు ఇట్ ముక్కు దగ్గర పెడతారు సమ్టైమ్స్ పీపుల్ ఆర్ లిటిల్ స్మార్ట్ దే నో హౌ టు సీ ద పర్సన్ ఇక్కడ పర్సన్ లేకపోతే this is where they will get the pulse but this is really difficult you need to have a clinician so it చూస్తాము చూసి use time okay so life అనేది ఒక basic there are 6 different basic principles to consider a person as a living reproduction కానీ he should have a metabolism he should be having the spine all these principles okay let us not get there so అట్లనే telomerase అనే ఎంజైమ్ క్యాన్సర్ సెల్స్ లో చాలా ఎక్కువ యాక్టివిటీ ఉంటుంది so telomerase are nothing but the ends of chromosomes these are 8 to 10 or 8 to 12 nucleotides that are at ends of chromosomes ఒక్కొక్క సైకిల్ లో సెల్ సైకిల్ అవుతుందంటే a portion of telomerase ఇప్పుడు RBC అంటే మీకు తెలుసు 120 డేస్ బతుకుంటాయి ఆ తర్వాత కొత్త వస్తాయి ఓకే అట్లాగే స్కిన్ ఎపిథీలియల్ సెల్స్ హావ్ షార్టర్ లైఫ్ ఇట్లా ఎవ్రీ సెల్ టైప్ ఇంత లైఫ్ స్పాన్ ఉంటుంది అట్లా మనం అనుకుంటాం కదా వాడికి దేవుడు 50 ఏళ్ళే రాశాడు వాడికి దేవుడు 30 ఏళ్ళే రాశాడు అట్లనే ఎవ్రీ సెల్ టైప్ కూడా ఇన్ని రోజులే ఉండాలి ఆఫ్టర్ దట్ దే డై అండ్ యు హావ్ ఎ న్యూ వన్స్ ఓకే ద ఓన్లీ సెల్స్ దట్ విల్ నాట్ డివైడ్ at only age is neuronal cells or brain cells glial cells you call them as brain cells at brain time general గా చెప్తాం will not go into much so but then it telomerase ఏం చేస్తుందంటే చచ్చిపోతానంటే చచ్చిపోనివ్వదు it starts more and more telomerase activity so cells keep dividing indefinitely because of the high telomerase activity appudu em avutundi telomerase length that is chromosome aberrations kellipotundi so you will have different chromosome aberrations and most of these chromosomal abnormalities lead to hematological blood cancers like lymphoma leukemia this one so telomerase activity is high okay so ee factors anni మనం కూడా తెచ్చిపెట్టుకొని నాకెందుకు నా ఒక్కడికే నేను తాగను నేను తిన్నా చెప్పిన అప్పటికే క్యాన్సర్ ఎందుకు వచ్చిందంటే who will be answerable for it okay we ourselves of course I will say there is a genetic component okay if your back generation or parents or grandparents have cancer or somebody is suspected to have cancer it is better to get genetic test done and then be careful it is not that see దాని అదేమవుతుందంటే వాళ్ళకు ఉంది నీకు రాకుండా చేసేది అనేది ఇప్పుడు వరకు అయితే లేదు ఓకే ఎందుకు తెలుసుకోవాలి అనుకుంటే మీరు అలర్ట్ గా వెళ్ళి డయాగ్నోస్ చేసుకోవచ్చు ఎర్లీ స్టేజ్ లో డయాగ్నోస్ చేసుకోవచ్చు so this is what genetic component is definitely there but then man-made factors are much more than the genetic factors anyway you cannot avoid chesed any level you better don't worry about it and do whatever you do but when there are man-made factors like your eating leading to increased free radical exposure or your cells are getting free radical exposure too much of everything so this leads ultimately to your DNA damage and then finally mutations happen and that is what leads to the whole concept of cancer okay idu okate ani kaadu there are several different factors that could contribute so ivanni manaki teliste targeting becomes easy madam next slide close okay కొంచెం పైకి సో ఇప్పుడు చూడండి ఆ హాల్ మార్క్స్ అన్ని మనకి నాకేమో చెప్పారంటే వరల్డ్ ఇప్పుడు నేను క్రికెట్ మ్యాచ్ లో ఒక టీంలో ఎంతమంది ఉంటారు 11 మెంబర్స్ ఉంటారు ఏ దేశం టీం వచ్చినా కూడా ఏ యుఎస్ పోండి యూకే పోండి జర్మనీ పోండి ఇండియా పోండి పాకిస్తాన్ పోండి 11 మెంబర్స్ ఉంటారు అట్లా ఈ హాల్ మార్క్స్ ఎక్కడికి వెళ్ళినా ఏ కంట్రీ కానీ ఏ డాక్టర్ చూసినా they should say that ఇవి ఉంటే క్యాన్సర్ సెల్స్ అనే కామన్ హాల్ మార్క్స్ ఆర్ కామన్ ఫినామినా ప్రపోజ్ చేసింది ఇద్దరు సైంటిస్ట్ దే ఆర్ కాల్డ్ వైన్బర్గ్ అండ్ హనహాన్ సో ఐ థింక్ వీ షుడ్ ఆల్ బి థ్యాంక్ఫుల్ టు దట్ వాళ్ళే కనుక మనకి హాల్ మార్క్స్ చెప్పుకుండకపోతే ఫస్ట్ ఒపీనియన్ నుంచి థర్డ్ ఒపీనియన్ పోయాం వీ షుడ్ గో ఫర్ 20 డిఫరెంట్ ఒపీనియన్స్ సో ఇప్పుడు ఏ డాక్టర్ దగ్గరికి వెళ్ళినా he follows these hallmarks okay these are called the hallmarks of cancer ఇవన్నీ తెలుసు కాబట్టి నెక్స్ట్ స్లైడ్ వెళ్ళండి మనము ఇప్పుడు ఉన్న సిచువేషన్ లో వి హాల్మార్క్స్ అన్నిటికీ వి హావ్ డ్రగ్స్ ఓకే ఈజిఎఫ్ఆర్ ఇన్హిబిటర్స్ సార్ చెప్పారు మీకు సైక్లిన్ డిపెండెంట్ కైనేస్ ఇన్హిబిటర్స్ ఇమ్యూన్ యాక్టివ్ CTLA4 యాంటీబాడీస్ ఓకే PD1 అండ్ PD-L1 యాంటీబాడీస్ వాళ్ళకి నోబెల్ ప్రైజ్ వచ్చింది telomerase inhibitors సెలెక్టివ్ యాంటీ NSAIDs అంటారు బట్ దిస్ NSAIDs will not but for cancer, at least is initial inflammation, you can start treating them. Inhibitors of VEGF signaling, Avastin is a monoclonal antibody which stops angiogenesis. PARP inhibitors for triple negative cancer, BH3 mimetics inhibitor, BCL2 inhibitors, aerobic glycolysis. So all these are possible. One last 50 years work comes out to see. If we have cancer cells ante, ee pathways activate ayyuntayi ani chepte, manaki ఇప్పుడు ఇక్కడ ఉంది టార్గెట్ అని చెప్పి ఇట్లా అంటే ఇట్ ఈస్ ఈజీ టు టార్గెట్. వాళ్ళు మనకి టార్గెట్ చూపించారు. వీఆర్ వర్కింగ్ ఫర్ ద హౌ టు target them. So the whole concept of targeting cancer is based on these hallmarks, and these hallmarks, 99.9% of all tumors follow these hallmarks. So which means that they are universally accepted round the world. Ee doctor dekhe ఏ drug ఇచ్చినాడో పక్క డాక్టర్ దగ్గరికి వెళ్ళినా అదే drug ఇస్తాడు, because he goes by the targets. Okay, so first second opinion is always better to get it, but then by and large, when you have certain principles, so cancer research goes by the principles and scientific explanation. So it is better stay yourself safe, don't get exposed. Of course, sometimes you cannot avoid it. So, but then cancer research has come a long way, and this research has done a lot of good to the public, and I'm sure it will keep improving. Once we get the precision therapy to India, I'm sure a lot of things will change. Okay. So with this, I will take, sure I did not bore you. I hope I did not bore you guys. So if there are any questions, I will be very happy to take. I'm not as good speaker as sir, but then the awesomeness.
Any questions from the students? Friends?
Yes, Thomas.
Yes.
Thank you for the talk, sir. I have a small doubt. In the recent few days, since most of the pathways as we have already explained, at the end of the day is actually triggering the upregulation of expression of gene. So that there are a lot of epigenetic factors that are also influencing the expression of these genes, like histone acetylases and histone deacetylases. How good is it to use this as a target? Because
see, when you come to HDAC inhibitor, there's one HDAC inhibitor which is already in the clinic. This is called, we know what is HDAC inhibitor that is in the clinic? SAHA. Okay? So HDAC 1, 2 are inhibited by this, but the problem with HDAC inhibitor, there are close to 11 HDAC 1, 2, 3, 4, 5, 6, 11 HDAC. The specificity of SAHA is to HDAC 2. Okay? Which means that this is a histone deacetylase inhibitor. Histone acetylation and deacetylation are, the balance need to be there. Histone acetylation shows up increased transcription. When it is acetylated, increased transcription. Deacetylated, decreased transcription. So by you inhibiting histone HDACs, okay, that is working as a very good anti-cancer therapy. But the problem is with the specificity, but still, despite that, SAHA is doing very good in the clinic. So definitely epigenetic modifications like methylation, acetylation, all these are playing very important role, and that is where in one of the hallmarks where you have these, see, these are the initial 6 hallmarks, and then, but then non-epigenetic and epigenetic modifications are proposed as different hallmarks also. So definitely epigenetic modification, targeting them will definitely control the tumor cells from proliferation. Yes, sir.
Very nice presentation, sir. Are there any early blood markers for P53?
Sir, the problem with P53, see, I said, sir, P53 80% అన్నారు కదా, ఏం చేస్తున్నారు సార్ తెలుసు కూడా. ఓకే, ఇంకొంచెం ఏం చేస్తున్నారు సార్, మీరు 80% అన్నారు, దాన్ని చూస్తే దాన్ని చేస్తే 80% ఆఫ్ క్యాన్సర్ విల్ కమ్ టు పేషెంట్. ప్రాబ్లమ్ ఈజ్ క్యాన్సర్ డ్రగ్ డిస్కవరీలో, ఎనీ డ్రగ్ డిస్కవరీలో మీకు మాలిక్యూల్ రిసెప్టర్ ఆర్ సెల్ మెంబ్రేన్ మీద ఉంటే ఈజీగా డ్రగ్ చేయొచ్చు. సెల్ మెంబ్రేన్ లో ఉంటే ఇట్ ఈస్ మోస్ట్ ఆఫ్ ద డ్రగ్స్ దట్ ఆర్ అవైలబుల్ ఆర్ ఫర్ ద మెంబ్రేన్. ఒక మాలిక్యూల్ సెల్ మెంబ్రేన్ నుంచి లోపలికి వెళ్ళి వర్క్ చేయాలంటే ఇట్ ఈస్ ఎ డిఫరెంట్ టాస్క్. ఎందుకంటే లాట్ ఆఫ్ ప్రోటీయేసెస్, లాట్ ఆఫ్ అదర్ థింగ్స్ దట్ డిగ్రేడ్ ద మాలిక్యూల్. సెల్ మెంబ్రేన్ మీద అంటే ఫస్ట్ థింగ్ సెల్ మెంబ్రేన్. ఓకే, మన దరిద్రం కొద్ది అది సెల్ మెంబ్రేన్ మీద లేదు. ఓకే, సైటోప్లాజం లో ఉందంటే కొంచెం ఈజీ. సెల్ మెంబ్రేన్ కన్నా డిఫికల్ట్ కొంచెం ఈజీ. బట్ వీడ్ అన్ఫార్చునేట్గా P53 గడిపోయి న్యూక్లియస్లో కూర్చుంటాడు. సెల్ మెంబ్రేన్ నుంచి సైటోప్లాజం అంతా దాటుకొని పోయి న్యూక్లియస్లో ఉంది, న్యూక్లియస్లో మ్యూటేట్ అయి కూర్చున్నాడు. వాటిని పీపుల్ ఆర్ ట్రైంగ్ టు యూజ్ జీన్ థెరపీ టు రీమ్యూటేట్ ఇట్. ఓకే, ఆ ఏ సెట్ రీమ్యూటేట్ చేద్దాం అంటే వాడు ఒక్క సైట్లో కాదు మ్యూటేషన్. P53 is a 53 kilo Dalton protein. అంటే ఇంతది, ఇంత చిన్నది కూడా కాదు, ఇంత చిన్నది అయితే ఏదైనా చేయొచ్చు. ఇంతది దానిలో వాడు ఒక సైట్ కాదు, there are close to 58 sites of P53 that are mutated in different cancers. ఎన్ని ఒక దానిలో ఎన్ని ఉన్నాయో కూడా we are still not able to identify. 58 mutate చేసుకొని కూర్చుంటే it is practically not possible. So that is where, sir, you know better than me. Okay, so that is where people have been trying to work to remutate P53. That is one option. Okay, unna mutation ni danni convert, suppose if serine gets converted into alanine anukondi. Okay, danni alanine chesesi normal P53 anante there are other mutations. Ippudu em chestunnaru P53 gene therapy ki they express P53 wild type P53. Ippudu em chestaru wild type P53 express chesthe it acts as a tumor suppressor. So adi try chestaru, but we were not there. I'm sure down the road people will be able to identify mutations, rescue mutation for P53, but it is a long way because it is a nuclear molecule and difficult to tackle. మీరు ఏ డ్రగ్ అయినా హెర్సెప్టిన్, EGFR ఇన్హిబిటర్స్ అన్ని మాక్సిమం రిసెప్టార్ పైనే ఉంటాయి, ఈజీగా ఉంటుంది. సో డోర్లో ఉంటే వెళ్ళి మనం తట్టొచ్చు, లోపల ఉన్న ఎట్లా తీసుకొస్తాం బయటికి. ఓకే, thank you.
And actually, if you want to treat the particular cancer patient, we have to prepare a special drug. Heterogeneous drugs have to be prepared to treat different people.
That is
because is it tied up with the HLA compatibility?
No, sir, it is not. See, HLA compatibility is different thing, but when it comes to receptor-based treatment, okay, so they look at the profile of that, what genes are basically responsible or what are the mutations. So that is what they are coming up with precision therapy. India lo inta raled sir precision therapy. Inkoka 10 ఏళ్ళు అవుతుంది అంటే అది ఈ ట్యూమర్ లో people are doing circulating tumor cells తీసుకొని genetic profiling చేస్తారు. ఇప్పుడు అపోలో కానీ when you go to bigger hospitals the treatment is good. దొబ్బుకోవడం కూడా బాగానే డబ్బు దొబ్బుతున్నారు. ఓకే, now cancer research treatment costs close to not less than anything you go to Apollo 10 to 20 lakhs. Okay, there are also advanced therapies like CAR-T cell therapy and చెప్పి blood cancers coaching, that's the most advanced, which costs close to 40 to 50 lakhs. Okay, so they are doing bone marrow transplantation and CAR-T cell therapy, but how many people are 50 lakhs of మంచి afford చేయాలంటే how many people are able to afford it? ఇంకా precision therapy పోతే మీకు diagnosis కే 50 lakhs అవుతుంది, తర్వాత మళ్ళీ ట్రీట్మెంట్. So but then at the end what is that is money unda, you will be able to, it's not, see, when even you spend money you will not get the treatment. But here the good thing is the standard of earning of people have gone up. Okay, manaki at least పాతకాలంలో 200, 300, 1000 rupees salary వచ్చి at least I'm sure now everybody is getting a decent salary. Standard of living has gone up, standard of earning has gone up. Likewise diseases పెరిగాయి. Okay, but then people are able to afford. There are a lot of people who go to Apollo or bigger hospitals get the good treatment. Okay, ఏదో అంటారు చూడండి, కాసుకి అయితే దోశ అంటారు తెలుగు తమిళ్లో, డబ్బులు ఎక్కువ ఇస్తే దోశ సైజ్ పెరుగుతుంది. అట్లానే if you have more money the treatment options. ఇప్పుడు రెగ్యులర్ గా నార్మల్ గా మనం ఇక్కడ చిన్న హాస్పిటల్ వెళ్తే they say okay radiation therapy, but when you go there the proton therapy, the reason why proton therapy is much more advanced, పక్కన నార్మల్ సెల్స్ కి డామేజ్ it is very precision. ట్యూమర్ సెల్ ఇక్కడ ఉంది అంటే it targets only the tumor cell, so the damage is lost. So it is basically became expensive, but expensive అయినా కూడా treatment is available. That is what you look at the end. Okay, thank you and stay safe.
Very nice of you, sir. Thank you for your nice talk on hallmarks of cancer. Now I request this technical session on Chair Professor 𝕃𝕀𝕍𝔼 sir to talk on this technical session. My take on, yeah.
సరే సింపుల్ గా చెప్పారు. what sir analyze is the recent trends in cancer research, the advances in cancer research, the problems in treating the diseases, because the signaling pathway is so complex, so it's very difficult to pinpoint where the problem is. So the research analysis, the developments and the problems, everything excellently complex.
Thank you. Now I request faculty of Department of Geology, Satai for presentation. Now the time is 1:30, lunch break, we will break for lunch and again assemble here at 2 o'clock. Okay?
and suits them. Then many things, other trends, everybody nowadays, life is taken in a different way nowadays. 50 years okay, 60 years okay, मर गए तो क्या हो जाता है, चलो ठीक है, खाके मरेंगे, ऐसा हो गया, that is okay. Everywhere there is a pollution, milk also polluted, what to do sir, okay. We are not trying to reduce it. This is what the mindset we are having now. Very unfortunate, but let us see, can we do anything? Next please. So, we have to discuss air pollution, particle, hair strand, people compare the hair strand and the particular material, 2.5, 10. Now what happens, have you ever purchased vegetables in Hanamkonda market or Hanamkonda roadside? How many vehicles it will be going from KDC? So, whatever the gas is or whatever is there, where it will go? Vegetables only, no? And how much time you will be washing them? 2 minutes. 2 minutes be washed. Very less, less than 1 minute. No? So what will happen? They all become chronic poison over a period of time. And you will not come to know whether how cancer has come. I am not eating tobacco and anything. That is what the reason. Okay. So, and food adulteration, yes, we discussed climate change. Extreme conditions, cold conditions, extreme hot conditions. This we are facing, humid conditions. Now, what happens? There is a biology system goes up, What happens when you drink water? Anybody student, like me, this will be a little bit interactive session. You should understand the nature, right? What happens once you take water? How many of you are, not now, regularly, chicken biryani? Vegetarian, pure vegetarian? Not regularly. How many of you like? All of you know. Kakarkaya curry, how many of you like? Yes. Oh, there are few people, very good. But many people doesn't like, no? So wherever, whatever you use, what happens to your human body? We are all science students, no? So you are taking water, you are taking coffee, you are taking whatever. What it has to happen? Over a period of time, it has to become you. Water has to become you, no? Otherwise it's a foreign material for you. You will vomit or somewhere it will go. So it should be edible. You can't eat gold, no? Even though it is very high price. I don't know why gold prices are high, sir. Usually I am asking the wrong person. Okay, sorry. So we can't eat gold. Why? Because it's a toxic material. Even though it is costly and sizzling. We can eat a little bit of rice, which will become you, right? It has to become you. So carbohydrates, proteins and fats, you will tell, no? Bodily tissues, it has to become. If it is not becoming that, it is a poison. Any material, for that reason, whatever you are consuming, like whether it is a vegetable oil or edible oil or whatever, burger, pizza, whatever, fruits, anything. That is personalized, that is what individual constitution. How many do you like the winter season? Okay, summer season? No. Rainy season? You don't like any season? Oh, so this is, how many of, now, I will repeat this question. How many of you like winter season now? Sir's likes, okay. Rainy season? Few people, no? Summer season? Oh, 2 people. So why seasons are there, no? Why this difference is there? No, that is okay. Why this variation is there? Liking is different. Because we are all as human beings same, but constitution is different. Constitution is different. So in modern medicine, the limitation is that particular constitution. Let us discuss this. It is not individual. One size fits all is a modern thing. One size does not fit all. Okay. So circadian cycle, generally all the creatures, generally, go to sleep at night, evening time, and we are waking up at 12 o'clock, 1 o'clock, then early morning, 7, 8, 9. What will happen? PCOD, polycystic ovaries, infertility, male infertility is also rampant. Lot of due to gene spikes. People don't understand the biology of human beings. People don't understand how they have to live. Very unfortunate. Simple things. Every infertility clinic is flooded with patients. Every cancer hospital is flooded with patients. There is a recent WHO warning that after 10 years, every fourth person will be getting cancer. Now imagine. Whatever is there, it will come. Only lifespan extension, that's all. So prevention and good immunity. Immunotherapy is coming now. In cancer, it is there already. But proper immunity is so important. Okay. So don't behind and go for sleep. Next slide. So where is the research point? No, we didn't come. Next. So limitation of the modern medicine. There is a positive angle also of the modern medicine. Emergencies, surgeries, there is there. But NCDs, like that 75% they have, right? So what is the limitation? Symptom focused. It is not treating the root cause. That is what the symptom focused. Fever hai, fever period are there. Like viral infection, bacterial infection, bacteria, you kill the bacteria. That's all. But we are not treating the root cause. Like obesity is there, you give some anti-obesity drug. There is no drug still for obesity. So like that. Side effects and drug resistance. Because the pure molecules not only targeting the cells which it has to target, it is also targeting the other things. That's why we are having side effects. There are known also because there are studied known side effects are there. And resistance. Antibiotics, majorly we are facing. Tuberculosis, major problem. Drug resistance is a major problem. Now, constant access. Sir was selling 50 lakhs, 1 crore. Sir, I know you have told the lesser price actually. If one cancer patient, he will be dying, nobody dies with a cancer. I will tell you. Emotional problems and due to drugs. The major side effects, you will not believe how the side effects. I don't know whether you have seen any cancer patient with chemotherapy and hair fall, lean, 50, somebody is 100 kgs, he will become half. He will become a half. Many side effects. And that particular patient will think, when I will die. Really, almost the majority of the patients I have seen, sir, my kab marunga, please. That is what's the problem with the cancer. We need to every morning, daily morning, we have to pray God, whatever the God. Sir, I said, this is Madhav. Health is wealth. That's why health is wealth. Next, chronic and complex diseases, immediate, metabolic disorders, complex mechanism. Many pathways, many tissues are involved, many hormones are involved, complex. Where you need to write many drugs you have to use. A list of drugs you have to use. Is that the, I have seen many patients taking 10 to 12 drugs daily. उनको बॉक्स रहता है मॉर्निंग डब्बा इवनिंग डब्बा वो ऐसा बना के रेडी रखते हैं है ना है इज इट्स ए healthy lifestyle health wise India is so low right so next please very unfortunate thing like I know how many of you from local and how many of you from villages nearby villages 15 kilometers 30 kilometers 50 100 no what happens one very good cardiac hospital is there in Hanamkonda. Doctors will tell and all the politicians will tell first half an hour is so important. You bring them. How I will bring from a Ethnomedicine? Remote place.
where actual thing has to be there. That defibrillator has to be there in that particular village. वो shock देते हैं ना आप वैसा फिल्म से देखा ऐसे ऐसा उठ ना defibrillator ना cardiac shock. First half an hour, first 3 hours paralysis, first 3 hours you can thrombolize and you can have a better life. How that particular person will come here? Even Warangal is also very difficult health conditions and doctors. You should not fall ill on a Sunday and a festival day. Very difficult to find out doctors. Hyderabad, okay, little bit, because tertiary care will be given. Very difficult. Where is the problem? Where we are treating? Fracture हो गया, ठीक है, 6 hours, 7 hours, next day also we can do. But cardiac and brain, they are most important organs. Cardiac arrest, brain, finish. So where we are treating, where we are going. So prevention is the only answer. We may not establish a big, in Mulugu or some colleges now, medical colleges, there is no staff. There is people from Hanamkota, they go weekly once or twice. There is no, minimum facilities are there. So how to survive? So immunity developing and prevention is the only thing, what we have to think. Up to almost all next to 20-30 years also the same situation will be there. Next. So single target we have discussed, one size does not fit all. And this is what you have to understand. Every human individual is different. Thinking is different. Food habits are, even in our family also food habits are, your sister will eat something, you will eat something. Your sister wants to see Ma TV, you want to see Star TV, some other TV, right? Cricket or something, different. We are different. Okay, next please. So what is the solution? Can this our Indian knowledge system or Ayurveda, Indian medicinal system, can it give some solution? Yes, a limited solutions Ayurveda can give. What is it? Like Prakriti. Prakriti means constitution, individualized constitution. You can type in Google Prakriti, how to know my Prakriti. You are lean, you are obese, some people restless, something or the other they will be doing. Some people, these are the traits, different traits. Entire human beings of the world can be divided into 7 traits. Vatam perigindi ani ullalo antuntaru. Pittam perigindi. Na pittam ekku itla yellow color. That is not basic pittam. Kapham, phlegm. These 3 are the major biological energies which governs our body actually according to Ayurveda. So Vata, Pitta, Kapha, those 3 traits, and Vata, Pitta, Pitta, Kapha, Vata, Kapha. Simple language, you will learn all those things. It's very simple. So these traits will be there. Some people like, Sama Ushna, Sama Shita, means not too cold, not too hot. There are Sama. Thinking also it will be like that, simple thinking. So this is what. Then Rasayana. Rasayana means not chemicals here. We have a different language, healthy aging and cellular resilience. So what happens? Now we are, feeling great that India is of more of youth. So this entire youth will become old after some years. There the problem comes, geriatric problem. I don't know, I think seniors who are sitting, they must have seen their father or mother's problem at the age of 80, 85. Alzheimer's, forgetfulness, fractures, many things. You can't be with them and you can't, you will not be happy, what you are doing to with them. There will be a major problem in next 10 years. This is what your opportunity. You think differently. So if you can give some nutraceutical, herbaceuticals or some supplements which can reduce your aging, that is called anti-aging drugs. That is what Rasayana. Rejuvenative and reparative therapy, which is called in Ayurveda. Reparation. Every day, why we should sleep? Anybody in this class, geology? Not teachers. Why we should go for sleep? What will happen if you don't sleep for 2 days? You will become Chandramukhi, no? Generally. Restlessness will be there, no? One whole night, you will become mad. No, some functions. Why? So, body repairs on its own. How many of you wants to eat at 12 o'clock biryani? Boys generally, no? 11 o'clock, 12 o'clock, kurshid and other biryanis, no? Generally. What will happen, I will tell you. Simple. You continue that habit or you stop. That is, my lecture will be, fruitful. What happens? Our body has to regain its power. Repair, it has to happen, no? So when you sleep, the godly thing starts. Where is God? Our whatever autonomic nervous system or whatever nervous system is God for us temporarily, and whatever God, whatever the name, I have no problem with the gods. So all gods are okay with me. So generally what happens? You don't command your heart to beat, no? Do you give command? Acha, I am going for sleep. Please continue the heartbeat. Do you give a command? Respiration also. You don't, who is commanding that? You name it as nervous system. Okay. Decent one. Because this is for learning. But you are a researcher now. Right? So why this happens? So it is automatic mechanism. It's the energy. Okay. We'll go into little bit deep. What is that one element which is devoid, you are called dead, and your plus you are called your life? One element which is devoid of that, you are called dead. Having that is called life. Live. Oxygen? No, oxygen is everywhere, no? If you die also, it will be going here and there, oxygen. We never thought of this, no? Because we are enjoying our lives. Good. That is called prana. So, soul will not go anywhere. In soul, about soul, everything is soul made. But it has to receive the stimulation from outside and it has to represent. Again, it has to talk, it has to express. That expression is going away. If you put, how many of you have taken, I think, cold drinks, no? I will not talk about alcoholic beverages. We will talk about the normal Fanta, I have, in some institutions we have avoided that, Coca-Cola or something. Every time same taste will be there, no? Generally. Why? How it will come? Because there is no fruit. If there is a proper fruit, it will have different taste. So no two fruits will be same in the entire world, right, sir? Mango also, mango, sitafale. So there are some chemicals and flavors and everything, right? But the thing is here, now once you take that, how the manufacturer is deciding that the same taste should have? So there is an electronic tongue is there. I think IIT is there, people working there know. Beer, brandy, alcohol रहता है वो same taste है ना? कैसे रहता है? कोई पिए तो नहीं tea taster जैसा नहीं रहता है उधर. Somebody has to taste it. No, every time similar. No, electronic tongue is there. So they test with that. So same taste, same sugar bricks and other things will be there. So this is what the science. Now why we are deviating with this? You need to know about the science and nature and how to, look at the opportunity what you are having. Futuristic opportunity. That's why there are so many issues are there. That is what next. So purification, time tested. Ayurveda is time tested 5,000 years back. First thing. Second thing is vast natural pharmacy. Almost 500 to 600 plant materials are used. Minerals also used. Heavy metals also used. And personalized care is there. Holistic integration. So body, nose, ear and everything we look at in a harmonized way. Dentist, I will not see ophthalmology. It is not like that. It is a holistic mechanism. Diversified procedures. External procedures are there. Internal procedures are also there. And preventive focus, main preventive, not to allow diseases to come. That is the main focus. Third thing, broad spectrum. Broad spectrum means metabolic disorders. There are so many medicines we need to use. So entire thing, one medicine can be useful. That is what? Safety, so safe. Since they are from the nature, they are safe, they are not having many side effects. And naturally bioavailable. So plants-based material are edible. They are not toxic to human body. That is what the advantage. Third thing is, last 10th point is lifestyle and diet. Every individual person can have a diet. You can make dietitians are highly paid in metros actually. So individualized diet you can take. Okay, that is what it is stored. Next, we'll go quickly. So the same thing, polyherbal synergy. So I think usirkaya, amla, Indian gooseberry, or karakaya, myrobolans, you don't know. Any other material, we can use any of the plant material for Ayurveda purpose. Like from tamarind to a small erva laneta. Kondapindi chetu, like we use in Sankranti, Gobbu Mamala Betrani, which is a very good medicine for urinary calculus. It will break the stone. Kondalanu pindi jese chetu, Kondapindi chetu. It is what? Pindikura, it is what? So, but if you mix all together also, synergetic mechanism, like Chyawanprash, I don't know, have you seen like boost, how it comes? Like earlier Amitabh Bachchan used to give Chyawanprash advertisement. It contains of 36 plant-based material. Very good immune booster. We'll discuss that. Okay, next. So I have, since we are talking about science and research, and zoology department is conducting this, I brought some C. elegans for you. So C. elegans, I don't know, it is a nematode. So I was working in an industry earlier. So we wanted to how you should do the lifespan extension studies in humans. Very difficult, no? 50 years is the lifespan of somebody. By giving something, how you can tell that he lived for 60 years by mind medicine? Impossible, no? So we have animal models. So C. elegans is one. This is from IIT Kanpur, Subramaniam and other people, Jabna Subramaniam, they did. So what happens is C. elegans lifespan is only 14 days or 15 days. So yeah, 14-15 days. If it lives for 17, 18, 19 days, it is the extension of the lifespan. Yes, this is what one model. This is what Ashwagandha. I think seniors must have heard of this name, Ashwagandha. Withania somnifera. It is widely available, it is cultivated. There is a proverb in general Telugu that Peru leni vyadiki penneru gadda. Like if you are unable to decide the name of any new disease, blindly you give Ashwagandha, Withania somnifera roots. It is an excellent drug with very less or no side effects. It is a very good immunomodulator. It is a strength-giving drug. You will get the horsepower by Ashwagandha. So it also increases the lifespan. How will it increase? By antioxidant therapy or working on mechanisms, means aging mechanisms. I am not aware of molecular biology very much, but meiosis, mitosis, telomerase. That these drugs are working there. This is what one. So here the purified ingredient is increased 20 to 21% of extra lifespan. Single Ashwagandha. Next please. So this is a Nisha Amalaki. Don't get confused. Nisha is Paspu in Ayurveda. Paspu means curcumin. Turmeric, and Amalaki is Amla. Usirgaya Paspu. Every diabetic patient should take haldi, turmeric and amla daily, almost 1 gram of that. Powder or juice, amla juice or turmeric. It is having lot of benefits like anti-cancer activities. I know turmeric you must have heard. Many anti-cancer. There are drugs also, curcuminoids are there. Now this, how to, like earlier it has been told, now what is the scientific evidence? Now if you see this, next slide, this is one Wister rats model, this is also zoology again. So this is what preventing cataract. What happens in a diabetic patient? Early aging, cataract, eye problem, retinopathy, nephropathy, all pathies will come to a diabetic patient. Cardiovascular problems, burning feet, nephropathy, neuropathy, everything comes will do a diabetic patient, even though it is under control. So, if you are taking this curcuma longa and 𝕃𝕀𝕍𝔼 officinalis, which is amla, usirikaya, paspu, haldi or amla, daily basis, what will happen? This group 1 is a control group, only normal saline is given, and I think power has gone. So what will happen is, animal model, this group 5 is enarpillary. There is a model, to induce cataract. So if you give Nisha Amalaki prophylactic before coming a disease, what will happen? You just see there is no cataract formation. This is what the beauty, if you take preventive, prophylactic. Prophylactic generally in COVID, people were taking Tinospora cardifolia, Tipatiga. Everybody used to drink some kada, something or the other. Prophylactic, that is what prophylactic. Why you wear a mask? Prophylactic measure. Why you wear a gloves? Prophylactic measure. That is what. So this is what prophylactic. Safe, haldi, daily we are eating, but we don't know how to eat. Now we put into a very, very warm oil, we mix it, and whatever curcumin or whatever is there gone. Deep fry. Vegetarian or non-vegetarian, you remember one thing, deep fried is not good. Even the non-vegetarian, cooked, boiled cooked is okay. Earlier our mothers used to do, boiled and cooked is safe, but fried, danger. Once you fried, gone, everything is gone. So this is what the evidence now. So can we not give in a capsule form or a tablet form, in a supplement form? Next please. Prophylactic. So this is one leeches we use, zoology. Again, freshwater leeches we use for medicinal purposes. Yes, there will be no pain. If you apply 10 leeches also, we use in lot of skin diseases. Psoriasis, baldness also. Baldness also we are using. And psoriasis and many dermatological disorders we are using leeches. So leeches, it is told in Ayurveda that what happens in leech, it will initially suck the only impure blood. Once it starts the sucking of pure blood, you will feel the pain. Otherwise, no pain. I don't know, earlier in what you call ponds, people used to go for swimming and everything. They used to cut off leeches and no pain. वो इतना बल्ज होने के बाद थोड़ा pain लगता था. That is what medically we do. We have a small fish pond like thing. We grow these leeches and we use for the treatment. Hyaluronic acid will be there, no? So there will be no coagulation, anticoagulation properties. Excellent. It is approved by US FDA also. Not India. After some days you tell what is Ayurveda to us only. No, that is what is going to happen. Now you can see a clear cut region. That is the leech there, black color, small one. There was a dermatophytosis is there. After leech therapy, only leech therapy. This is a published paper in a Elsevier publication. It's not a simple publication. I have not taken simple publications also. So, gone. So there are so many uses of leeches also. Next please. So now everybody is talking about diabetes. Diabetic capital of world is India now. Obesity and diabetes. So cellular mechanism, receptors. We need to understand basic thing about diabetes is early diabetes, early age, non-insulin diabetes. There is a insulin in blood, but it is of no use. Useless insulin is there. Why? Because insulin along with glucose, it will be absorbed to the tissues and there will be no high glucose levels in the blood. But that receptor is not working. That receptor mechanism has gone. That's the major problem in the diabetes, non-insulin dependent diabetes. What is happening with the receptor? There are so many reasons. Major reason is fat covering. Simple language, layman's language. So If you remove that, normalcy will be coming. Now the trend is reversal of the diabetes. You see in Instagram or YouTube, there are so many people talking about reversal of diabetes. Earlier it was not there. Once diabetes has come, it is lifelong. But it is not lifelong. In my clinic itself, we have treated 3 patients. Now there is no medicine. In a scientific seminar I am talking. With evidence I am talking. No medicine, only diet restriction. If you are calculating in calories, please calculate in calories. If you are calculating in proteins, carbohydrates, something, yes, please. Anyway, human body is same. That is what you have to understand. So, 1000 kilocalories for a normal person, some aggressive work is there, 1200 to 1400 calories, 1800. So, there is a limitation. You restrict that, that's all. And you do some exercise like metformin and other drugs are there. What they will do, it will increase the muscle uptake of glucose. Otherwise, you do exercise. Bachpan mein, like, in childhood, whatever PET we used to do in our schools, that is the only solution. Or some Surya Namaskaras. Stretching exercise. I will tell you once, so I don't know, time is there not, but scientific seminar will go away, but some small thing, I will take only few minutes more. What happens is, if you are walking for 10 kilometers, 5 kilometers, still you will have cardiac arrest. Blockages will be there, cholesterol formation will be there. You will, even though you are doing for 5 kilometers a day and 10 kilometers. So where is the problem? You need to understand, it is not the walking it will give solution. It is the stretching it will give solution. You need to stretch your body. That is why yogasanas plays a major role. That is why our ancient Surya Namaskara plays a major role. You stretch. Simple walking, 20 kilometers of no use, you will have a cardiac arrest. But if you are stretching daily all your muscles, no fat. And if you are obese, blood cholesterol may be low. If you are thin, your cholesterol may be high in blood. There is nothing to do with obesity and leanness of blood cholesterol. So these are the minute things you have to understand and you have to think in a different way. What is the solution for this? And there is the opportunity. Okay, so this is what, okay, we will not go into the details. Next. So this is what insulin, normal insulin mechanism, insulin resistance, even though it is blood, there is of no use. Hyperinsulinemia will be there. That's why so many people who are having this black colored neck, black color jinka ho raha hai na, acanthosis, in medical language we call it acanthosis. Some warts will be there. So that is what hyperinsulinemia. Be careful. They are pre-diabetics. You need to treat them properly. Next. Next. This is what, sir, methi has come. This is what? Trigonella. How in liver the glucose uptake will be monitored by methi. It is a very, like if you are taking a lot of methi, menthulu, you will be hypoglycemic. If you are taking lot of karela also, you will be hypoglycemic. It is not anti-hyperglycemic. It is hypoglycemic. But metformin is anti-hyperglycemic. It will not lower the glucose after some time. That is what important. So there are so many mechanisms in diabetes also. Next, Karela, Nishamalaki. This is Podapatri. First thing is Podapatri. I don't know, in villages you must have learned. It's a climber, Podapatri. Do you know, once you eat Podapatri one leaf, up to some hours you will not feel the taste. If you eat sugar also, it will be like a sand. Yes, I am having at my college. If somebody wants, I can give you some leaves. You can just taste it. There will be no taste for some time. Paresthesia will happen. Next. So recent advances, I think sir must have talked about docking, molecular docking and in silico studies. So the problem is the herbs and other things. You need to know the problem. One usirikaya will be having vitamin C, gallic acid, ellagic acid, tannin, so many phytoconstituents. Like that, if you are having a polyherbal formulation, mixed vegetable curry, how many phytoconstituents will be there in that? Hundreds. Hundreds of phytoconstituents will be there. So hundreds of phytoconstituents will be working in 100 and double of pathways. So can any human being do a research module on that? Almost all next to impossible. Sir, that is what sir told, what you call, sir, PG or what you call, 453, I think, gene, something. P53 gene. Cancer gene. Difficult. You cannot, human life cannot discuss and they cannot talk. But we are getting the results. So for that, this in silico and network pharmacology will help. So molecular docking and molecular dynamic simulations and virtual screening and absorption, ADM, ADMET prediction, understanding the herb target interaction. Any medicine will have food interaction also, drug and food, before food, after food, that's why we tell. There will be interactions. So we can, accelerating phytochemical drug discovery is the new discovery now. Next please. So we'll discuss one point, anything. Now this is a molecular docking studies of crocus sativa, kumkumpu, saffron, curcuma longa, cassia occidentalis. Do you know cassia occidentalis? Chennangi. Urlalo. Tinevar idarku Chennangi aakto, like curries we used to be. In this Balasumudra market we will get now still Chennangi. Very good source of many vitamins, Chennangi. And Moringa oleifera, Shigru, the most traded herb from India to foreign countries is Munaga Aku, not Kadal. Leaves. People are eating like mad people, all in capsules. Munaga Papu we used to, now what is happening now? So when we are doing this molecular docking, we will come to know where it is working. This is a key and lock mechanism, receptors and how it blocks. This is what molecular docking. Network pharmacology is little bit different. So this is what we can do. This is a computer simulation. You just put the input and it will show where it will work. So by that you can go for a lead. No need to work on animals or anything. You can directly work on that particular model in a clinical or other model. This is what the beauty of in silico studies. Next please. So this is a network pharmacology, Chandra Prabhavari. This is an Ayurvedic formulation. So they new hope for the treatment of metabolic syndrome. Metabolic syndrome difficult to treat. Lifestyle modification, food modification, medicine, 3 are required. So in this one particular polyherbal formulation, how it works, they have studied now. Next please. So how many ingredients it is having? Next, 37 ingredients. How many recognizable phytoconstants will be there in this 37? Any guess? That is Vasakomu, that is Karpuram, Arati Karpuram, like that one Karpuram. Vasakomu, Tunga Mustalu, Musta is Tunga Mustalu. In village people they know. Bunimba is Kalameg, Andrographis paniculata or other things. Guduchi, Tinospora cardifolia. If you go like this, you will get Tinospora cardifolia. Wonderful drug. Amruta, there is no death to that. It works like that also. So there are so many things. Pippalu. Even in the villages now also after post-pregnancy, Pippalu is given. Shunti and Pippalu is given. So there are so many. Next please. So there are 167 compounds. Where we can isolate them at least. Unknown are many. 167 compounds can we study? What is the pharmacology of that? Impossible. Single paracetamol, single molecule, which pathway is very difficult. It takes 12 to 15 years, 150 crores. That is what research is industry driven. Government से नहीं होता है वो. Industry ही करता है, industry formulation लाता है, doctor को बताता है और doctor लिखता है. Like you people, chemists and zoologists, botany people, you help all the doctors actually, pharmacist people. Doctor को उधर बैठ के लिखना है बस उतना है. Devices by physicist and chemist. Means molecules. Everything brought to stethoscope was invented by a scientist, but we are using. BP apparatus, mercury BP apparatus invented by some scientist, but we are using. We are the end users. But still we are great. We know how to use it, no? That's the thing. So 160 or 167 next. How beautiful this is, pharmacology. Very difficult to understand also, It looks beautiful, but very difficult to understand. These many pharmacological actions are there in minute level and pathology. That is what the advantage of polyherbal formulation. Wholesome. Don't drink Grape juice, eat grapes. Don't drink Danima juice, pomegranate juice. Please eat total pomegranate. That is what the message. Wholesome is always good. That's why more polished, more white looking rice, more glucose, more harm. Which is so white in hue, rice, sugar, salt. 3 very dangerous. For India, white people were dangerous at some time back. Okay, next please. How many actions? So we can estimate by network pharmacology what percentage of action is also there. Probable action. Like 30%, 7%, like we can have a p-value there, probability value. Based on that, we can go for that particular activity. There may be so many activities, but major activity we may go if the p is less than 0.05, which is significant, this side or that side, right? Okay. Do you know జిల్లేడు, అర్క, calotropis, జిల్లేడు చెట్టు, ఆమదం చెట్టు? You heard of that, no? Ricinus coming, no? Have you seen rice plant? Rice tree? It is not tree, no. Okay, thank you. No, why? Because we should know our nearby things, no? We don't eat జిల్లేడు, no? Why? How do you know that is poison? Somebody told, no? This is what our ancient knowledge. It is poison, but all the poisons can be used as a medicine. That is what by molecular docking and network pharmacology you can go to some extent. Next please. So conclusion, what they made conclusion based on network pharmacology, almost all it is working in metabolic syndrome. METS is metabolic syndrome whenever it comes there. So including obesity, dyslipidemia, inflammation, hyperglycemia, many things. Even at mitochondrial level it is working. Now the science is developing. So we can have now the evidence. Without evidence also it is okay if it is working. That is what generally it is told. Next please. So the same thing, ashwagandha, COX-2 inhibition, pain reliever, all your aceclofenac sodium, diclofenac sodium, they are all COX inhibitors, COX pathway inhibitors. So ashwagandha works, curcumin, NF-kappa B, then guduchi means tipathiga. The greatest immunomodulator available in the world in India is tipathiga, guduchi. Stem we had to use. Stem. Excellent immunomodulator. Excellent means excellent. At the same time, it is having anti-gout properties. If somebody is having highest serum uric acid levels, please go for guduchi. Tipathiga, very safe. It will not create any side effect. The side effect of the plant is giving good health. If it is any side effect, it is amruta. There is no amruta. There is no death for that particular plant. Okay, next please. Network pharmacology, we have discussed this. Next please. Triphala, I think you must have heard some people, who is having constipation problem, people take Triphala churnam with lukewarm water they drink, and there will be a easy motion in the morning. Happy motion, that is called moksha. So Triphala consists of amla, harda, beda. Amla usrikaya, tanikaya, karakaya. Greatest treasure given by our ancient people. Triphala. If you change the dosage and how to take it, like water soluble or alcohol soluble or powder, anything, you can use in hundreds of diseases, only one single formulation. Earlier people, now the plants are not available. Karakaya, people used to cough, they used to just chew, that's all, finish. It's a very good, no other medicine is good for constipation. Triphala you take, daily you are having a happy motion. Mild laxative. If you take in more quantity, drastic laxation. Yeah, diarrhea will happen. No, anything over is anything. Water also, water is good for health. You go and dip into the water and kata, finish. That is what, food also, anything over is ati sarvatra varchet. Next. So, So there are so much of evidence. So neuroprotective. If you want to stabilize mind and good brain health, you go for ashwagandha. Calmness. One company where I used to work, now the company is 2,000 crore company. Can you believe it? Only ashwagandha product is there. They are exporting ashwagandha like anything. Tons of materials, sir. This is a Hyderabad company where 15-20 years back I used to work for the company. Ashwagandha, adaptogen, anti-stress. It increases the stress-bearing capacity. Like if you 3 people are there, if with a mechanical some stick, same force you have been beaten on your palm, same pain you will not have. Different. Why? Perception. Stress is a perception. That's why don't take stress. Give. Give to teachers, your friends. Don't take. If you are taking, that's all finished. Inflammation starts. Stress is the major factor for many diseases now. All are coming to stress. Physiological, mental, everything is stress now. So ashwagandha is one of the things. There are so many studies on ashwagandha. Next. Guduchi we discussed. Shetavari. Pilli pichara gaddal antaru in Telugu. Very good galactogam. Mothers after delivery who are not having the lactation, means breast milk, there is no medicine in modern medicine. People take shunti and other things. Shetavari. Shetavari kalpa, their granules are, even modern doctors also writing. It increases the breast milk. There is no other medicine. It's like a mother. Asparagus racemosus. 100 roots will be coming. It's a xerophytic plant. It's a climber. Available everywhere. Next. Tulsi we know, for cough and cold we use. So what are the global opportunities? Before, like only 2 slides. Next. Yeah. First thing is integration with omics technology. What is omics? Is a new word. Omics technologies. DNA level, RNA level, protein level, metabolite level. If you are working with technology, there is the market. Scientific evidence you can create. Then, now the WHO Global Center for Traditional Medicine is established in India at Jamnagar. Over entire world center is in, because they believe that Indian traditional system of medicine, that is Ayurveda, is having more knowledge than any of the indigenous system of any other country. That what I am talking. So if you are calculating, US billions, these are not this one, $1 billion. This is the growth expected, 2030. Next please. So, but challenges are there. We need to know standardization is the problem, because here Tipatika is different. My garden Tipatika may be different. Phytochemically it may be different. Mango, this plant, different. So standardization is a major problem in the plant materials that we need to address. Regulatory requirements, legalities we have to check, and large clinical trials. If you want to go for mass public, any supplements, we need to do a larger number of, like one patient I have reduced, no. We need some sufficient data. Then bridging traditional art with modern validation is also need of the hour. Now, next please. Next, conclusion. Future lies in the integrated system of medicine. Ayurveda provides holistic framework. Computational biology provides mechanistic validation. Collaborative research is essential. Research is all money, funding. No money, no research. You can do still research. small projects you can do. Without money also there are some projects you can do that you need to think, but funding is required. So that's why it is all industry driven research. You need to be careful. Next please. So thank you. So each one I request to plant one plant, not tulsi moka, big tree. You know, each one plant one. Without plants there is no human life. We need to think. How many of you have planted trees by this 100? Any? 10? 1? But big one? Small, no? Not in kundis. Pots. Please be careful about nature. It will protect you. Vruksho rakshite rakshitaha, like that. Thank you so much for giving me this opportunity. It's a very small thing. We are not going to details, but overall Ayurveda and what it tells. Okay, thank you. I think, yeah.
I request chairperson of this session, Professor 𝕃𝕀𝕍𝔼, to come on to the dais.
Good afternoon, everyone. I think it will be good evening. Good evening, sir. So thank you, Sridhar sir. So it is a very wonderful information and wonderful talk. So during the talk, actually, we are in classroom, but during the talk we are in forest or we are in park like that. So why? Because actually we are studying the syllabus in your books, completely Western syllabus. You know that? Did you know that? Actually, MBBS people are also studying in the Western syllabus, except Ayurveda. For example, if you take allopathy, the syllabus is completely westernized syllabus. So therefore, if you went to doctor, doctor says you take meat for proteins, right? You take meat, non-veg for proteins. But after some times, after 35 years of age, if you went to doctor, then the same doctor tells that don't take meat. So that is two different words from the same doctor, from the same patient. So what is the mistake here? We are on the westernized syllabus. But this complete session is our Indian syllabus. So the central government introducing this type of Indian knowledge system in our degree and PG curriculum syllabus also. In NEP 2020, the government said that just incorporate our Indian knowledge system in your syllabus. So like this subject should be incorporated in our syllabus. Then if we not incorporate that particular syllabus, we are not Indianized, we are not nationalized, we are westernized. So from this also, so degree college I request, so degree college or zoology faculty I request him, if you modify the syllabus, if you want to revise the syllabus, just incorporate the all Indian knowledge system related topics in our according to syllabus. So this will helpful to prolong our age. Like already Sir says that the life aging, senior Robert is there is an example. The ashwagandha root extract just increases the life of that particular animal. The telomerase enzyme or telomere is a part of a chromosome which enhances our lifespan. If you stop the degenerate your telomere, then you can survive more than 100 years. So that is the age marker for the age marker, the telomere, right? So that is the thing. So these are all. What is the Indian knowledge system saying that if you follow this Indian knowledge system, and automatically the lifespan is also increasing, right? So thank you, sir. Thank you, wonderful of your lecture. So now the talk is for open. So if you want any questions, you can please. So this is most important. The one-side lecture is not important. Two sides. Questions compulsory.
Yes, yes. Very good answer. I think I was about to leave. I was telling madam that I will not be leaving, but you have made me see clear. The good thing is only one thing that there is a misnomer, I would probably say, that this line-based system takes long time to see the results.
Yes.
Okay?
Yes.
Because nowadays we are like fast food. Everything we want it to be seen in 2-3 days. But then what is your say on this?
No, it is correct, sir. Which acts fast, it will have side effects. That's all the thing. Like there are medicines like, econitum we use. Econitum verax, which is a poisonous material. We use 𝕃𝕀𝕍𝔼 also. Like, 𝕃𝕀𝕍𝔼. We use many poisonous materials which acts like this, but there will be certain side effects. Which acts slowly, yeah.
In less quantity.
Less quantity also there will be little bit of side effects. I am having a paracetamol like medicine, 𝕃𝕀𝕍𝔼, which is in Malayalam it is called, which contains this econitum. Once you take 25 milligrams of econite, profuse sweating will happen. Sir, recently one person died with this 𝕃𝕀𝕍𝔼. Yeah, 𝕃𝕀𝕍. But it is a very good anti-inflammatory drug. So this was thought by our acharyas earlier. But what they thought, like, if you are doing quickly, there will be some side effects. Because it takes body to realize everything, sir, how many days it will take for an infant to come for a solid food? First 6 months, the beauty of human body we need to understand. Emergencies, cut, paste, everything is okay, surgery. For the first 6 months, the babies are only milk, but entire bodily system is developing. Why bones are developing? Why brain is only milk? Even elephant, we used to learn that it eats only sugar cane. Generally, no sir. Only sugar cane for entire life, that much of big, all bones, fat, muscle, everything is. So this is not the beauty of the nature. You can, this is E is equal to mc square. Anything can be, sir. In Prahlada and you need to know the science and energy levels of it. Archimedes, when Archimedes says you give me a lever so that I can move the earth like this. That much long lever, I can just move the earth, he said. It is theoretically correct. If you can use that much of long lever, he can move. So, but sir, there are medicines still. We are very quick medicines. We are using that. But there are certain side effects. We need to give very carefully. That's the only thing. We are using that. But in chronic diseases, we need to give very slowly. That's all. Sir, diabetes, very slow. Lifelong you are taking medicine. Nobody is asking. Hypertension, lifelong you are taking medicine. Nobody is asking. Mental disorders, Alzheimer's, no medicine. Nobody is asking. Knee joint pains, there is no medicine. Only knee joint replacement with restricted. Nobody is asking. Spinal problems, backache, lifelong medicine, only painkillers, liver damage, cardiac disease. Nobody is asking. Like sir, emergencies, yes, modern medicine has an edge. There is no doubt. Surgery, there is an edge. But chronic ailments, food and some herbal medicine, supplements and lifestyle modification is enough. All the lifestyle drugs. So that is what. Sorry, we had.
ఆముదం ఒక డ్రాప్ మోస్ట్ బెనిఫిషియల్. 1 డ్రాప్ కంటే ఎక్కువ తీసుకుంటే సైడ్ ఎఫెక్ట్స్.
అదే సార్ యాక్చువల్లీ ఎంత క్వాంటిటీ తీసుకోవాలి
Quantity is important. Dosage is so important.
యాక్చువల్గా ఒక ఆకు తినాలి సార్. ఒక్కటి తినాలా, 2 తినాలా, 4 తినాలా అనేది మాకు తెలియాలి కదా మాకు.
Common people. That's a medicine. No, that's a secret of a doctor. Otherwise, you will only become teenage.
ఆ బుక్స్ కావాలి.
No, there are books. We can.
You can lie with your body. You can lie with your body.
No, we are having lot of hair oils also. We are having many things are there, sir. Like supplements, we are having many. But only.
కిడ్నీ కూడా పప్పులో వేసి అనుకుంటే కిడ్నీలో రాగి అనుకుంటారు. అసలు ఎంత క్వాంటిటీ వేసుకోవాలి అని ఎందుకంటే
We will tell, sir. That's not the issue. That is what integration. That is what is integration. Sir, what is happening? You are living your mind is not professional. You are living your way. We are living our way. Sir is living sir own. This is what integration. Sir, Why we are doing all these things? Every IIT, NIT, all ICMR, everybody is working for whom? You, me, those students. Human being, comfort, time, health. At the end of the day, there is no integration.
Good sir, very good.
No, that's it.
Thank you, sir.
People feel bored. No, that's okay.
So one more question from the audience, from students especially.
No, you can do small studies actually, geological studies. Where we use rapid data also. We use many of the animal material. We use horns, antlers, medicine. But now it is restricted, but we can use. The same material can be used.
We are all of our staff members may call you to be
No.
every day.
I request this is the platform because you know all the a woman after 35 should take some of the other supplement for her own health, at least her muscle. All the women, you give to your mothers, you take yourself, and you give to your what you call daughter-in-laws also and daughters. Important, sir, because sir, we are unable to treat old age problems after certain conditions.
Saturation.
Mocha no sir. Very difficult to treat.
మీ ఆయుర్వేదవి చాలా బాగా పనిచేస్తుంది. ఒకసారి ఇట్లా జాయింట్ పెయిన్స్ వస్తే వావిలాకు ఇచ్చారు, తగ్గిపోయింది నాకు. ఎక్సలెంట్ అది.
Excellent medicine.
పెయిన్స్ వచ్చినాయి.
There are many medicines, sir.
30 days వాడినాను సార్ నేను. ఏ డాక్టర్ దగ్గర పోతే ఎంత కాస్ట్లీ అయ్యేది నాకు. నేను ఎక్స్పీరియన్స్ ఏది ఎంత వాడాలో తెలియదు, అక్కడే ఆగుతుంది. మీరు అన్నట్టు సిలబస్ లో కూడా పెట్టుకోవాలి. సిలబస్ లో ఇంట్రడ్యూస్ చేసుకుంటూ
కరివేపాకు పౌడర్ ఆర్ కరివేపాకు జ్యూస్ like 1 teaspoon like we were having menstrual cycle pain period type excellent otherwise jeera sir మీకు అన్నం అరగలేదు అనుకోండి you are feeling indigestion take half teaspoon to 1/4 teaspoon of jeera you will see the difference. That's all. You want Pantoseed is a dangerous thing. Narasimhan who is a very great cardiologist, electrophysiologist cardiologist, he told me, don't use pantoprazole, esomeprazole and ranitidine. It will not allow your B12 intake. It will not allow your D3 intake. Very dangerous.
Thank you.
Those are all the classics.
First first రాసేది.
Please go for nature. Okay.
Okay, sir.
Thank you. So we will get this. So we will have a photograph. Some girl or somebody can take it on mobile. You can share.
Now it is a time for presentation of my exhibit.
Screen ఆపాలి. Screen ఆపాలి.
దానికి ఇంత క్లారిటీ No sir, full yes or yes.
I don't know. Some of them if you put more credit will be late. Sir, please. Yes, sir. Very nice. We never made that in time. We are
Thank you.
Practice
And I will take care.
Level college
No, sorry, sir. Thank you, sir.
కదా
So these are all the things we are not doing.
Next invited talk is by Professor M. Sir. And for this session, Dr. K. Sridhar sir will be the chairperson. Now I request Gauri Madam to be your Professor Sir's vice.
Very good afternoon. Welcome back to the session. So far, we had 3 fruitful sessions which are enriched your knowledge, and this session is going to enlighten and broaden the concepts which you have understood so far. Let me introduce the speaker of this session, Professor 𝕃𝕀𝕍𝔼. He is a professor of geology at Keynote University, Telangana, India, and he worked as a head for the Infectious Diseases and Metabolic Disorders Research Laboratory. His research focuses on infectious diseases, particularly HIV and emerging viral infections, along with metabolic disorders such as diabetes. Professor Manitala has successfully completed and led more than 10 major funded research projects supported by agencies such as ICMR, DDT, DST, UGC, and RUSA. He has published over 150 research papers in reputed national and international journals, including high-impact index publications. Additionally, he has contributed to the innovation through patent filings and intellectual property development in drug discovery and biomedical research. In addition to research and teaching, Professor Manitala has served in important administrative roles at Kakatiya University, including Director of Hospitals and Dean of Student Affairs. He is member of the Royal Society of Biology UK and a fellow of several scientific bodies. Through academic leadership, mentorship, and institutional service, he continues to promote research excellence, student development, and innovation in life sciences and biomedical research. With these few lines, I invite Professor 𝕃𝕀𝕍𝔼 to deliver his talk. Thank you.
So again, good evening. So after lunch it is very difficult to talk, to listen. To talk is no problem. To listen is it is very hard, right? So I will try to నిద్రపోవడానికి ప్రయత్నం చేస్తా. మిమ్మల్ని నిద్రపోవడానికి నిద్రపోతారా పడుకుంటారా? మేల్కుంటారా? ఏమో సార్. Yeah, very good. Okay. So the talk is on emerging strategies in infectious diseases therapeutics. Emerging strategies in infectious diseases therapeutics. That is from ethnomedicine to molecular target. Again, we came here to ethnomedicine, right? So the very important thing is here the infectious diseases. So why the infectious disease is very important? Just a few years ago, approximately 5 years ago, a small virus, right? Just it is most dangerous virus. We cannot see that particular virus without electron microscope. But the virus came into homes. Each homes, ఎక్కడైతే ఇంటింటికి నీరులాగా ఉన్నది కదా గవర్నమెంట్ స్కీమ్. సో అట్లా ప్రతి ఇంటికి వైరస్ ఇట్లా టచ్ చేసి వెళ్ళిపోయింది. So how many are just infected with the COVID? Yes, almost. Somebody with the immune system, so they are not, the symptoms are not appeared, but almost the maximum. But after 2-3 years, the virus is completely eradicated, right? But 3 years, the thing is, the most is dangerous. ఎందుకు dangerous అంటే ఇప్పుడు మనం ఏమంటున్నాం కోవిడ్ బిఫోర్ కోవిడ్ ఆఫ్టర్. ఏదైనా మనం చెప్పాలంటే ఏమంటున్నాం కోవిడ్ బిఫోర్ కోవిడ్ ఆఫ్టర్. సో అట్లా ఒక ఎరాను సృష్టించిపోయింది. సో దట్ ఈస్ ఏ కోవిడ్ వైరస్. సో దేర్ఫోర్ టు లర్న్ దిస్ ఇన్ఫెక్షియస్ డిసీజెస్ ఈజ్ మోస్ట్ ఇంపార్టెంట్. సో వీ డన్ సమ్ రీసెర్చ్ in this particular area and what we did and what is the general topic on the infectious diseases, so we can discuss in this lecture. So here this is global example of emerging and re-emerging infectious diseases. So some diseases are only outbreak in specific area, but maximum infectious diseases are emerging in total globally. So for example, if you take in this diagram, for example in American countries, so there is a this particular H1N1 influenza and enterovirus and Nile virus. So these infectious diseases are outbreak or emerging in this particular area, that is American area. And when coming to the African area, especially, so this is Zika virus and Ebola virus and especially HIV. We know that HIV from where? HIV comes from where? Which country? African. SARS from where? Corona. China. Right. So these are the specific infectious diseases which are most emerging in this particular Africa, that is HIV, monkeypox and Ebola virus and also Zika virus. When coming to our continent, that is Asian continent, here, so this is one MERS and another one, that is Nipah virus. So like these diseases and some other infectious diseases also. Therefore, with the taking of this map, we can conclude that the not infectious single disease is not specific to single country, right? Maximum 90% of the infectious diseases are occurring in or emerging in globally, right? So if you look in this is global distribution of 7 most prevalent infectious diseases. That is during the 6 months only. From the 6 months, so these are the one cholera, monkeypox and dengue and measles, malaria, Zika virus, chikungunya fever. So these are important 7 diseases emerging in this during only 6 months, that is from June to 2025, right? So these are more important infectious diseases. And coming
what is the main causative factor for these infectious diseases? అసలు మీకు ఏమైనా రోగాలు వస్తే దేని మూలంగా వస్తాయి చెప్పండి? ది మెయిన్ ఈజ్ ఎయిర్, మెయిన్ ఈజ్ వాటర్. వితౌట్ దట్ ఈ రెండింటిని మనం కంట్రోల్ చేస్తే జస్ట్ మనం అన్ని డిసీజెస్ని అవాయిడ్ చేస్తుంటాం. దట్ ఈస్ మోస్ట్ ఇంపార్టెంట్. ఎయిర్ అండ్ వాటర్ కంటామినేషన్. Viruses, microorganisms or bacteria, viruses or any microorganisms are contaminated into your food or contaminated in air. So that we are taking. So therefore, these are the diseases. So for example, if you take the bacteria, the total how many number of bacteria species are there? Till to this 541 bacteria species, but among the 541 bacteria, 87 bacteria are emerging or caused infectious diseases that is reported in between 1980 to 2025, like this. So almost we can take DNA viruses and also RNA viruses. For example, if you take HIV is DNA virus or RNA virus? RNA virus, right? So like that, so many viruses are, some viruses are RNA virus, some viruses are DNA virus. So these are the number of species, but the disease caused species are like this. So therefore approximately 1399 total microorganisms species. Among these 1399, the 87 species are causing the infectious diseases. So that is reported in between 1980 to 2025. And this is major outbreaks. That is from 1998. Also re-emerging infectious diseases. So if you see here, in India, yes. So this is a Nipah virus. We see in the Nipah virus in India 2018. But when coming to the COVID-19, it is a global pandemic. That is also starts from 2019. And another disease, H1N1 virus. This is also global pandemic. So this is emerged in 2009. So like this. So there are different. So what are the main important factors here? Number one is change in human susceptibility. So that leads to the causing in diseases and change in, these are different factors, right? Next, coming to human infectious diseases. So this is non-zoonosis, that is 39%, and the zoonosis means animals. Animals are responsible, 61% animals are responsible for the infectious diseases, and non-zoonosis is 39% diseases are comes from the non-zoonosis. So is it non-vegetarian is recommended or vegetarian is recommended? Which one is recommended? Both are recommended. ఏది తినకుండా ఉండాలా? ఇది తిన్నా 39% diseases are comes from the non-zoonosis. And if you take the non-veg also, 69% of infectious diseases are comes from the animals. For example, HIV came from the animal, and corona, it is also came from the animal. Many diseases are like that, right? So therefore, so these are the some diseases which are responsible for the infectious diseases, that is called as zoonosis. And these infectious diseases are divided into three categories. Number one, category A. So which type of diseases are category A? The disease which transmits from one person to another person, right? Easily transmitted from one person to another person. So this is category 1. And another one is it transmits from one person to another person, but transmission rate is moderately, right? So that is included in the category B, right? So like this, there are different categories of these infectious diseases. So this is very important. So how to maintain the data of these diseases means how to maintain the strategy in-depth profiling of the infectious diseases. Already Sir said that there are so many techniques to control these diseases. First we want to learn, so what is the animal health and how the human health is affected, and how the environment is affected. By these three important factors, the infectious diseases are rising. So therefore, to prevent these diseases, we need to collect the data from these three criteria, that is animal health and environment and human health. For example, how the human health is very important. We need to take specific diet and we need to maintain the social determinants, and also if the loss of diversity, then environment become polluted, and then water and air pollution, the environment become polluted, and if vector infections by the intensive farming, the animals are get causing many diseases, right? So therefore, we need to collect these particular data to maintain this strategy, right, for these particular infectious diseases. And after collecting the data, we need to go analytical techniques. There are so many analytical techniques out there. So for example, genomics, transcriptomics, proteomics, metabolomics. In the previous lecture, we did that. So there is DNA, DNA to mRNA, mRNA to protein, and protein to, that is called as proteomics, transcriptomics. The study of these are very important. With these analytical techniques, in your syllabus in molecular biology or cell biology or in electrophoresis, will have it. Chadwar electrophoresis, blotting techniques, yeah, gel electrophoresis, SDS page and age agarose gel electrophoresis, right? So these are three are very important techniques by which we can identify the particular DNA or particular RNA or particular protein of that particular disease causer, right? So therefore, we need to analyze this. These are the analytical techniques. And after completing the analytical technique, we need to collect the data. So that is called as data analysis. If you want to do research on something, we require some statistical data. Without that, we cannot do. Without statistical data, we cannot do experiment in your labs. So with the statistical data only. So for example, if you want to do research on infectious diseases, yes, you want the data for the infectious diseases. For example, if you want to study on malaria or if you want to study on HIV, so how much HIV is a pandemic and what is HIV? We need to study. And what is the different routes of contact transmission? So we need to know that particular literature before the study, right? So to analyze the data, we need the demographic data, we need the animal data, how many number of animals are infected, so what is the category of that particular animal is infected, right? Right. So this is the data. So we need to provide DNA data, we need to require what is the sequence of that particular. For example, if you want to study the coronavirus, we need to we require the sequence of that particular spike protein or particular protease protein of that particular corona. For example, if you want to study on the HIV, you need to sequence of the reverse transcriptase enzyme or protease enzyme. So what are the targets are responsible for that particular disease? So we need to know that particular sequence, right? So that is this data is required. So like this data analysis, and after data, then the another research is data integration. We need to integrate the whole data to the experiment, right? So this is the completely strategy for the in-depth profiling of the infectious disease. So in this, so is this myth? So what is myth? So we are using mobile phones. All are using mobile phones or any other thing? Evarana mobile phones lekunda unnara? We are using mobile phones. Using of mobile phone means that is electromagnetic radiation. You know that? Electromagnetic radiation, that is called as EMR. Is it beneficial or is it harmful? Harmful. Why you are using phones? We know that, but we are using. Cigarette smoking is injurious to health, we know that. But the people are taking. Liquor taking is injurious to health, we know that. But the people are taking. Doctor is also know that, but doctor taking the cigarette and also doctor taking the liquor also. So that is the right? So that is our westernized syllabus, right? So, electromagnetic radiation, we know that. We know that that is harmful to our body, but we are using phones. But the today technology is there, today generation is there. If you are not using mobile phone, మీరు మొబైల్ ఫోన్ యూజ్ చేయకుంటే మిమ్మల్ని ఎవరు మీకు ఫ్రెండ్షిప్ కూడా చేయరు. సో అట్లా తయారైపోయింది. ఇప్పుడు ఐఫోన్ మొబైల్ ఫోన్ యూజ్ చేస్తే ఐఫోన్ మొబైల్ ఫోన్ యూజ్ చేసే వాళ్ళు మీకు ఫ్రెండ్షిప్ చేస్తారు. డబ్బా ఫోన్ యూజ్ చేస్తే ఎవరు వస్తారు మీ దగ్గరికి? నో ఫ్రెండ్స్ అవుతారు. డబ్బా ఫ్రెండ్స్, రైట్? సో సార్ కేటగిరీ చేసేసారు డబ్బా ఫ్రెండ్స్. సో కాబట్టి వీ నో దట్, బట్ వీఆర్ నాట్ ఇంప్లిమెంటింగ్ థింగ్. సో ఇదే బేస్ మీద ఒక మిత్ వచ్చేసింది మనకు. ఏం మిత్ వచ్చేసి చూడండి. In 2003, 3G introduced. What is meant by G? Generation, right? Nidrasuna? Right. So what is meant by 3? G is generation. So third generation eప్పుడు start అయింది? 2003 లో generated, right? Start అయింది. So that is to the world. అదే same year లో the outbreak. What is the outbreak? SARS outbreak. The same year. What is the relation between EMR and that is a different thing, but just check the logic thing. And again in 2009, the 4G is introduced to the world. దాంతో పాటుగా బోనస్ ఏమొచ్చింది? స్వైన్ ఫ్లూ అవుట్బ్రేక్ వచ్చేసింది, ది సేమ్ ఇయర్. అండ్ అగైన్ ఇన్ 2020, 5th generation ఇంట్రడ్యూస్డ్ టు ది వరల్డ్ రీసెంట్లీ. కాబట్టి ఇంకో ఎక్స్ట్రా బోనస్ ఏమొచ్చేసింది? కరోనా వైరస్ 20 బ్రేక్. వై? Right, buy one get one, right. Ingo main important, 6G is ready to come, that is in 2030, 2030. Inkoka 5 years unnadi. Yeah, 5 years lo 6G vastadi. So then what is the disease? Inko logic chudandi, all 3 outbreaks are related to respiratory diseases only. SARS, swine flu and coronavirus are respiratory diseases. Direct తీసుకుపోతే పైకి. నో హాస్పిటల్ అడ్మిషన్. ఎందుకంటే మనకు ప్రాణశక్తి సార్ చెప్పాడు కదా, ఏ శక్తి మనల్ని ఆపుతున్నది? ప్రాణశక్తి, నాట్ ఎయిర్, దట్ ఈస్ ప్రాణశక్తి, రైట్? సో అది తీసుకొని వెళ్ళిపోతుంది. సో దట్ ఈస్ ది, సో వాట్ ఆఫ్టర్ 2030 దెన్ 6G ఈజ్ ఇంట్రడ్యూస్డ్. సో యాక్చువల్లీ ఇట్ ఈస్ ఎ మిత్ ఆర్ నాట్? సో లెట్ వి కన్క్లూడ్. So actually we know that EMR, electromagnetic radiation, there is a 2 types of. One is non-ionizing, second one is ionizing. So this is non-ionizing. So based on the scientist explanation, the non-ionizing radiation is not harmful to our body. నేను హార్మ్ఫుల్ లేదని చెప్తలేను. ఎవరి డెఫినేషన్ ప్రకారము సైంటిస్ట్ చెప్పిన దాన్ని అట అంటాం కదా, వాళ్ళు చెప్పారట, అంతే, దట్స్ ఇట్. సో దిట్ ఈస్ non-ionizing radiation which is not harmful to our body. But when it comes to the ionizing, that is UV, X-rays and gamma rays, it is also harmful. మనకు తెలియదు. So this radiation is comes to under ionizing. ఇక్కడ సైంటిస్ట్ డిఫెన్స్ ఎట్లా చేస్తారంటే, ది 6G is also non-ionizing radiation, 5G also non-ionizing radiation. ఇవన్నీ కదా, సెల్ ఫోన్స్ ఇవన్నీ కూడా, మొబైల్ ఫోన్స్ ఇవన్నీ కూడా 5G జనరేషన్, 6G జనరేషన్ వరకు ఇవన్నీ non-ionizing radiation. So they are not affecting on body. అది పెద్ద మార్కెట్, అదొక పెద్ద మార్కెట్. చూడండి ఇంకొకటి చూడండి. సో ఎవల్యూషన్ ఆఫ్ 1G to, వాట్ ఇస్ ది డిఫరెన్స్ బిట్వీన్ G? 1G అంటే 14 kilobytes per seconds. సో అట్లా స్పీడ్ మారుతూ ఉంటుంది. 5Gలో 1 to 10 gigabytes per second. సో ఈ స్పీడ్లో ఇమీడియట్గా తీసుకుపోయే స్పీడ్ ఎక్కువ, డిసీజ్ కలిగించి హార్మ్ఫుల్ చేసే స్పీడ్ పెరుగుతూ ఉంటుంది అన్నమాట. సో ఇప్పుడు చెప్పండి, ఈజ్ దీస్ 6G ఆర్ 5G ఆర్ 4G? అవుట్బ్రేక్స్ వచ్చినాయి కదా మనకు, 2003 సార్స్, అండ్ ఆఫ్టర్ దట్ 2009 స్వైన్ ఫ్లూ, అండ్ 2019 ఏది కరోనా, అండ్ 2030 there is a question mark. But the scientists claim that, so this is only myth, so this is not a fact. So మీరు దీన్ని నమ్ముతారా నమ్మరా, that is a different thing. So this is just so these are completely data of the infectious diseases. Next, what are the challenges in the current therapy to treat that particular infections? It may be corona or it may be HIV or any infectious diseases. So these are the main important 4 challenges. Number 1 is drug resistance, toxic side effects, limited broad spectrum antivirals, and long and expensive drug development process. Another is HIV. అన్నిటికీ వ్యాక్సిన్ ఉన్నది, but we don't have the vaccine for the HIV. complete vaccine. Recent vaccine but not complete. Complete vaccine for the HIV. Why? What is the reason? Anybody? Anybody? Why the HIV is not having the vaccine? The other diseases having the vaccines. Why? So this is the first important drug. This is the most important challenge to control the infectious diseases, right? So there are two important, one enzyme that is HIV reverse transcriptase enzyme. There is a mutation is most important. The rapid mutation of these virus, right? The rapid mutation of these virus protects themselves. దాన్ని ప్రొటెక్ట్ చేసుకుంటున్నాయి, రైట్? ఒక వైరస్ స్ట్రక్చర్ని మనం ఇన్వెంట్ చేస్తాం. If you discover that particular drug to bind that particular virus protein, then the protein sequence, if you change that particular virus, then the drug will not work. The drug will not work. Again we need to discover one more drug to bind that particular protein. మళ్ళీ కనుగొన్నాం అనుకో, again the virus again changes its one amino acid. So this is the one amino acid. There is lysine 103rd amino acid that changes mutated to aspartame amino acid. So like that, all the drugs invented to treat the HIV are complete failed. So due to the mutation. So this is the very important challenge, right? And another important disease, influenza neuroaminidase resistance. So this is also mutation. 275 histidine amino acids mutation into tyrosine amino acid, right? So that is responsible for the influenza disease, right? So this is the drug. And here in HIV auto we are using NNRTA, non-nucleoside reverse transcriptase inhibitors, right? So these are all comes under drug resistance due to viral mutations, right? So this is one important challenge. If you come to another important challenge, that is toxic side effects. So if you are taking the drugs, there are toxic side effects. So for example, if you take the 𝕍𝕝, this is for HIV. So this is, while effective long-term use of AZT can cause bone marrow suppression, anemia, and also mitochondrial toxicity. So if you use long time, then automatically these are the toxic effects are there for this particular AZT drug. Next, another one, and ribavirin. So this is the ribavirin in the COVID period. The ribavirin is also in some areas. This ribavirin also used. This associated with the hemolytic anemia and is contracted pregnancy due to 𝕃𝕀𝍍. So long exposure of these particular drug or long time treatment of these particular drug, so that gets more effect. So therefore, the toxicity of that particular drugs are very important. Another factor, right? Another challenge. Next, the third challenge is limited broad spectrum. So what is that? So for example, the virus specific targeting, that is, this is the drug. So this drug against the influenza but has no activity against HIV and SARS and hepatitis virus, right? So that specific drug works on only HIV, like that. And another one is COVID-19 therapeutic gaps. So during early COVID-19 waves, very few antivirals were available, highlighting the absence of broad spectrum agents effect against novel. We have not used a new drug to treat the corona. They already, what are the existing drugs are there, just we used that existing drugs to treat the corona. So therefore, so this is one important another challenge. And the last fourth challenge is, there is long and expensive drug development process. To develop a single drug, it takes minimum 10 years, more than 10 years, right? More than 10 years. So that is to cure or to discover a drug to control these infectious diseases is a very challenging issue, right? So therefore, so this is right. Okay. So 10 to 15 years development timeline on a new drug takes over a decade from discovery to approval with billions of dollars invested. But in COVID period, not like that. The vaccine is approved within 6 months. So that is emergency. That is no other option no other option is there. So that is an emergency. But to take the official approval, So minimum 10 years required. And another one, high failure rate. 10 సంవత్సరాల తర్వాత నీకు అప్రూవల్ వచ్చింది. Or otherwise, if you in your clinical trials, if the drug is success, but ఒక కండిషన్లో 90% drug candidates fail during clinical trial. 10 years డెవలప్ చేసిన తర్వాత క్లినికల్ ట్రయల్స్లో ఫెయిల్ అయినాయి అనుకోండి, ఈ టైం అంతా కూడా వేస్ట్. ది కంప్లీట్ టైం అండ్ ద కంప్లీట్ expense completely waste. So this is another challenge. So therefore, so these are the 4 important challenges for the current therapy to treat the infectious diseases. Right. So next comes to the why ethnomedicines. ఈ challenges ని మనం ఏం చేయాలా? Challenges ని overcome చేయాలి. To overcome these challenges, so మన Indianized system వచ్చేసాయి. So that is ethnomedicines. So these are the traditional medicine systems contain century of empirical knowledge. Tribal communities in Telangana use plant-based remedies for infectious diseases. So our lab surveyed on Telangana, almost 6-7 districts we covered. We went to Khammam district, different places. We went to Adilabad district and we went to Mulugu district, like that. In where the tribal communities are used, right, traditional healing methods to treat a specific infectious diseases, right, we interviewed them and we collected data, right. So for example, so this is one data collected from the Khammam district. So these are the 2 places. In these 2 places there are traditional healers are there are tribal people, they are using medicines, means medicinal plants to treat diseases, infectious diseases like malaria, like HIV symptoms, right, syphilis, gonorrhea and chlamydia. There are different dangerous very symptoms are completely treated with the help of this tribal community, right. So we collected the data from that, right. So like that. And another one, so this is from the Mahabad district, that is Maripeda. So here also one tribal community is there. They are now also they are giving the different traditional healing. Ministers, MLAs, VIP persons are also visiting their house to take the remedy to get out from that particular diseases, right. So that is most important traditional knowledge is there, right. So we collected from that particular community the data, what are the medicinal plants and how they are preparing that particular extract and what is the ingredient they are using to treat particular disease. So we have collected that particular data from the also this Mahabad district. And also we collected data from the Adilabad district. We know that Adilabad is a very tribal area, that is Gonds and Lambadas and other communities are there. So we visited, these are the different places, and from these places the tribals are there. They are giving some ingredients of which is made from the different medicinal plants, and they are like trying to treat the infectious diseases, right. So we are also collected from this data. And then after that, so what we do that, we need to extract the particular what are the major components, phytocompounds are present in that particular plants. So these are the very important phytocompounds, that is flavonoids, alkaloids, terpenoids and phytosterols, right. The single medicine, for example, if you take allopathy, if you are taking any tablet, the tablet is containing only single formula, that is single, right. Single formula means, for example, if you take a Calpol tablet, what it have? Only paracetamol. So there is only one chemical is present. But when coming to the ethnomedicines, here there are flavonoids, a bunch of flavonoids. If you take the crude extract, in the mundu sir chepparu, muluga aakulu, crude direct ga, we have that flavonoids and we have terpenoids also. So mixture of the 2 type of phytochemicals, right. So like that, the mixture of phytochemicals, that is called as polyherbal formulation. Polyherbal formulation is most beneficial when compared to the single drug formulation, right. So that is most important, that is very beneficial in this ethnomedicines. So we are taking that particular collected data, means collected plants, and we are extracting these particular phytochemicals from that plants. And for that, we got some patents are also. So we can depth PG scholars. So here one is the medicinal plant that is called as in plant extract. So in this patent we used some 4 different plants. So we prepare the extracts and we tried for the anti-HIV activity, that is we are trying to reverse transcriptase inhibition activity. So for that we got the patent from the Indian Patent Office. And another also, so this is 𝕃𝕀𝕍𝔼 alba. We know that 𝕃𝕀𝕍𝔼 alba. So gunta kalagara. So that is the plant. So that is Bhungaraja, right? Bhungaraja. మీరు వెంట్రుకలు నల్లగా ఉన్నాయి తెల్లవాడడానికి కూడా వెంట్రుకలలో మ్యాక్సిమం వాడుతూ ఉంటారు బృంగరాజ. సో దిస్ ఈస్ మోస్ట్ ఇంపార్టెంట్ ప్లాంట్. సో దిస్ ఈస్ ఆల్సో HIV reverse transcript inhibition of this 𝕃𝕀𝕍𝔼 alba. So these all patent means this type of information is just only comes from the traditional healers. Just we are trying to explore the traditional knowledge into the society, right? So that is our try. Next, so after that, so this is complete pipeline from tradition to target, right? So what is tradition to target? So what is the traditional knowledge? Traditional knowledge is very important, right? From tribal community or from Ayurvedic knowledge. So this is traditional knowledge. Next, from that traditional knowledge, it is required to isolate the chemicals or extracts or different type of phytochemicals, and after that, to reduce the time, here we will go to the computational screening. I already said in first class or before one class also, that is molecular docking, dynamic simulation and admit properties, right? So these are all in computational screening. So if in computational screening, if the positive results come, then after that we will go to the experimental validation. If you miss this, directly if you do this experimental validation, if the experimental validation is unsuccessful, then the time is also wasted and money is also wasted. So therefore before that, the computational screening is very important, right? So then after experimental validation, we need to go the theoretical development. Theoretical development means there are clinical trials are there, phase 1, phase 2, phase 3. First we need to prove in vitro study, then we need to go in vivo study. In that in vivo study, we need to go animals, rats, rabbits and monkeys, and after that we need to go phase 1, phase 2 on human. In human also again there are different phases. The number of population is less, and again we need to more population. We need to take more population. Again we need to take thousands of population. So these are the different stages. That is comes under therapeutic development. So here there are 2 important infectious diseases. One is HIV and another one is SARS. So we did work or research on these 2 infectious diseases. So in this we are selected the targets. To control the infectious diseases, we need to know the knowledge on the targets. So which targets are responsible for the multiplication of that particular virus? For example, if you want HIV, then there are 3 important targets are there. One is HIV reverse transcriptase enzyme, and second one is HIV1 protease, and third one is HIV1 integrase, and also CCR5. So these 3 or 4 are very important targets. For example, reverse transcriptase. What is the function of reverse transcriptase? Anybody?
RNA to DNA.
Yeah, RNA to DNA, DNA to RNA. RNA to DNA. So that is the function of reverse. If you block the reverse transcriptase enzyme, so therefore the viral RNA cannot convert into viral DNA. So therefore they stopping the multiplication. So that is the target. So for example, protease. So to mature the particular other proteins of that particular virus, the HIV protease is very important. So if you block the protease enzyme, then the maturation of virus will become stopped. So therefore automatically multiplication of virus become stopped. That is the another second target. Next come to the another one, that is CCR5. CCR5. This is entry inhibitor. Entry inhibitor. So what is the entry of HIV virus to our body?
What place?
What is the entry? Which part? For example, corona. What is the part?
T4, TH lymphocytes.
Yeah, this is lymphocytes. Peripheral PBMC cells, lymphocytes, right? Coronavirus, what is the
Lungs.
entry part? Lungs part, right? So here, our body cells are C3, CD8 or CD4 cells having a specific receptor, that is CCR5 receptor, that is called as chemokine receptors. These particular virus attached to this particular chemokine receptors, right? So to block, if you block these chemokine receptors, then automatically the virus not attached to your cells. Some persons are there, in that persons, in blood, HIV is positive, but the symptoms are not there. Why? Because the receptor of that particular cell is not accepting that particular virus, means the receptor structure is different. That is called seronegative patients. కొందరికి పాజిటివ్ అయితే ఇమీడియట్గా ఆ సెల్ లోపలికి వెళ్ళిపోతుంది వైరస్. సీరో పాజిటివ్ అని అంటున్నారు. సీరో నెగటివ్, సీరో పాజిటివ్. కరోనా ఆల్సో లైక్ దట్ సేమ్ థింగ్. Corona acts on our lung cells. That is one enzyme, that is ACE2, angiotensin converting enzyme. ACE2 enzyme is there. So that is very important, right? So that is the entry part of the coronavirus. Here the chemokine receptors, CXCR5 receptors are entry part. So therefore CCR5 receptor. So this CCR5 is another target. When coming to the corona, protease enzyme is there and also spike protein is also there. Spike protein. This is the entry part of our lung cells, right? So these are the main important targets responsible for the multiplication of that particular viruses. So next, so we worked on this 𝕃𝕀𝕍𝔼 already. Sir explained 𝕃𝕀𝕍𝔼 𝕃𝕀𝕍𝔼, right? So 𝕃𝕀𝕍𝔼, that is against HIV, just recently published in Springer Nature paper, right? So we did in silico and also in vitro assay, right? So ఇవన్నీ ఇంతకుముందు కూడా సార్ కొన్ని పబ్లికేషన్స్ చూపించారు, right? Next, another one. So we tried on protease. In this slide we tried on reverse transcriptase key enzyme, and in this we tried on protease enzyme, right? And we taken the plant that is also same 𝕃𝕀𝕍𝔼, but we extracted steroidal cardinolats, right? So this paper is published in Indian Journal of Medical ICMR journal, right? So this is molecular interaction. So this is a structure of that particular ligand drug, and these are the amino acids of that particular protease enzyme protein, right? Next, another important target for the HIV infectious disease is CCR5 entry inhibitor, and we did also this. We targeted this CCR5, right? And we developed CCR5. We did some work on CCR5 inhibitors, right? So what is the in silico flow? So in this in silico flow, we need to select the target structure retrieval. Target structure అంటే for example HIV1 or SARS coronavirus. So the virus is not there in the databases. The only targets are there. So just go to the PDB database and just download your particular sequence. If you want to select HIV1 RT, then you can download from that particular database, right? So therefore sequence retrieval is very important from the selected target. So there are different databases are there. RCSP, PDB database is there for that. And next, after that, ligand preparation. So already we some ligands means some phytochemicals. If you want to extract some medicinal plants, ethnomedicine, you can extract. So these are the ligands. So that selected ligands are one there, and pharmacophore model. This is another important area of in silico screening. Pharmacophore model means there are two types of pharmacophore. One is structure based and another one is ligand based. If you don't know the structure of that particular virus target, just go for the ligand based. If you know the structure of target of that particular virus, then you go for the structure based, right? So for example, if you go in structure based drug design, what happens? If you know the target, that is HIV1 RT or any spike protein, if you know that, so you need to just collect the sequence and what are the active sites of that particular protein, you need to collect that information. and then which type of ligands is able to bind on that particular active sites. Right? So this pharmacophore model will develop that particular ligands. Right? So that is called a structure based. And when coming to the ligand based, if you don't have the don't know the target of that particular disease, just to go for the ligand. So for example, the target structure you don't know, just the standard drug you know, just take that drug, take that compound structure and just collect the similar drugs of the similar drugs and then go for the pharmacophore model. Similar drugs means the main is drug function is based on the functional groups present on that particular compound. For example, in some amino group is there, in some compounds OH group is there, in some compounds aldehyde group is there, in some compounds ketone group is there. So there are side chain, right? So like that, so there are different pharmacophore models out there, right? So we need to collect the information from there in the third step. Next, coming to after that, we need to go for molecular docking, and if the binding energy is sufficient, right? If that particular ligand is binds to the active sites of particular amino acids, then we go for the dynamic simulation. In that dynamic simulation, what is the binding stability of that particular ligand and target enzyme? So that will known in the molecular dynamic simulation. So we screened plant-derived compounds against HIV-1-RT. Reversed. So this is HIV-1-RT enzyme structure, and this is the ligand. So this ligand binding into the active sites of this HIV-1-RT enzyme. So this is one of the paper published, recently published, and this is another paper. This is the target of the CCR5. Next. So another one is that is published in the Science Direct. That is phenolic compounds are extracted from medicinal plants and did against the COVID-19. Right. So this is also in silico work. So this is the COVID-19 protease enzyme. Already I said that this is the one target. So this is the active site of active pocket of that particular viral enzyme, and this particular drug is binds to this particular active site. Right. So this is also published in one of the important journal. So this is a 3D model. So we did also some repurposing drugs. Repurposing drugs means in COVID we did that. Means we all used chloroquine phosphate and some other. ఏది వాడారు మీరు? ఫస్ట్ ఆయన అన్నాడు కదా, సీఎం కేసీఆర్ ఏమన్నాడు, పారాసెటమాల్ సరిపోతుంది అన్నాడు కదా. సో ఇట్లా మనం కొన్ని డ్రగ్స్ వాడాం, కానీ దాని కొరకు కాదు. ద డ్రగ్స్ ఆర్ మేడ్ ఫర్ నాట్ ఫర్ ది కోవిడ్, బట్ వీఆర్ యూజ్డ్. సో ద డ్రగ్స్ ఆర్ కాల్డ్ as repurposed. The drugs are used to treat during the COVID period. So we did this work. So that is inhibitory. This is one of my project work. Inhibitory potential alpha amyrin. It is one important compound which is isolated from 𝕃𝕀𝕍𝔼 procera. తెల్లగన్నే రితం చెప్పాను, right? White arc, జిల్లేడు, శ్వేత ఆర్క అంటాం మనం. Root of the that particular 𝕃𝕀𝕍𝔼 procera అని అంటాం, right? So we did in silico and in vitro. So this is the one important alpha amyrin isolated, and we did molecular docking, drug likeness features, pharmacokinetic prediction, in vitro analysis, and also admit production. So what is admit production? Yeah, the drug should be absorbed well, the drug should be distributed into the body, the drug should be metabolized in specific period, the drug should be excreted, the drug should not be toxic, right? And what is drug likeness features? What are the drug likeness features of that particular compound? The number of hydrogen bond donors, the number of hydrogen bond acceptors, the rotatable bonds. So these are different parameters are there, right? So to know is the drug is able to druggable or not, the compound is druggable or not. So this is the one that is epigenin derivatives. So this work is published in the Taylor and Francis. Epigenin derivatives from norovirus RDRP. So this is DNA dependent, RNA dependent RNA polymerase. This is a target for the norovirus. So we collected some epigenin. This is a very useful for the cancer treatment, and we collected some derivatives of this epitinin and we did the work on this against the RDRP norovirus, right? So this is the active site of that particular norovirus, and this is the compound binding with the active sites of this. So what is the conclusion? Infectious diseases demand innovative solutions. Next, ethnomedicine provides valuable lead compounds. మనం ఎంతమంది చెప్పిన వెరీ డ్రగ్ టాక్సిక్, ఏది తీసుకున్నా డ్రగ్ టాక్సిక్. డాక్టర్ దగ్గరకు పోతే ఒక డ్రగ్ రాయడు, రోగం ఒకటే, మందులు 4 ఉంటాయి. ఎందుకంటే వాడు ఇచ్చే మందుకు సైడ్ ఎఫెక్ట్ తగ్గించడానికి ఇంకొక మందు ఇస్తాడు, సైడ్ ఎఫెక్ట్ తగ్గించడానికి ఇంకొక మందు ఇస్తాడు. బట్ కాబట్టి we need to go Indian knowledge system. So that is ethnomedicine provides valuable lead compounds without side effects. Molecular targeting enhances research. Molecular targets. So we need to know the target. Next, computational tools accelerate drug discovery. So computational tool reduces the time, reduces the expenses, right? Next, integration in the future of antiviral therapeutics. What is the integration? New techniques and with traditional techniques. So we can integrate. If we can integrate them, that is the only future of the antiviral therapeutics. So what is the final conclusion? Bridging traditional knowledge with molecular precision provides a sustainable and powerful strategy to combat infectious diseases. The integrative approach represents the future of the next generation therapeutics, right? So our research projects funded by ICMR, UGC and DBT New Delhi and TS Cost, DST New Delhi and TS Cost, and this is RUSA, right? So these are the funding agencies. We got the funding from there and we did the research. Okay, thank you. Thank you.
Congratulations, sir, for a wonderful and precise, to the point presentation. So, everybody is now coming to in silico studies and molecular docking and network pharmacology, right? Generally, like last 2-3 lectures, and in future also it will be there, because to reduce the time and cost. As sir said, it is a very tedious process to develop a drug in modern science. It will take a lot of energy and vitamin M. Money. Vitamin M is money. Yeah. But you can't eat vitamin M. And it is almost all, sir said, 100 to 150 crores of rupees to, for a drug to come into the market. And 10 to 15 years of time. And that's why last few decades there are no new drugs. As such, there is some adjuvant drugs are coming. Cephalosporins or antibiotic, great generation, next generation is coming, but there is a new thing. Because it's a tedious process and in between anything may happen. And what happens is in 10 patients, if it is okay, for 100 patients it should be okay, 1000 also it should be okay. If one of the person gets some side effect, it will be withdrawn during the study only. And post-marketing also there is phase 4 in clinical trials, post-marketing surveillance, that is called pharmacovigilance. So pharmacovigilance, there are many drugs which has been withdrawn after in the market, like rafecoxib. It was withdrawn, there was some angiogenesis and other things were there. So cardiac issues were coming of that painkiller, COX-2 inhibitor. So it was withdrawn from entire world. So there are the risks, but in traditional medicine and this plant-based things, there is a safety issue. That is what the advantage. That is what the advantage, and you can isolate the structures also later. That is what sir is talking. Initially you can get the lead, and then you finalize the what molecule and what site you want to work. Then you extract it, in extractions. And you can isolate that particular, and it can be a pure compound also later. It can be a crude compound. It's as a algada mottam tinochu, lekapothe andlo pure edana starch compound, some flavonoids you can take. That is both the things. So thank you very much, sir. I was not aware. I know sir for many years, but I was not aware. Even though we are here in the same city and we meet often, but I was not aware sir is working on that. Sir I would also like to work like this, and there is a project proposal. This is what networking happens in seminars. There is one private project. If you are ready, there is a ready-made project which can be funded by an industry for in silico studies and molecular docking. There is ready. If you okay it, because we wanted to give to Hyderabad or some Bangalore companies, but if you are ready, we can do it. So that's what you can, don't think what is happening here. Think futuristically, like Istari sir is there, how to get hold of him and what project I have to know, some publications or something, think in that line, all the youngsters and seniors, that is what the advantage of, learn one new thing a day, sufficient. So thank you sir, congratulations. Any question and answers can be taken up. Simple thing, it's a new technology, it's all computer based, but still you can ask some questions. Ethnomedicine, I used to work with SAI Raju sir. We used to go with 𝕃𝕀𝕍𝔼 where tribal population is there. They need to trust us. Then only they will tell us what is there. Vajedu and other places we used to travel. I like Bhadrachalam also, Utnur also, a lot of flora is there. What is happening? Biodiversity, certain plants, trees, big trees, which are very much useful. Only in that particular area, one tree will be there. So we need to geotag that. We need to make a passport. Passport means where it is located in longitude, latitude, and we need to protect. Once that particular tree is gone, finish. That is what urbanization problems. Almost 20-25% of the forest are going in each decade. That's the problem. We are all planting all flower plants, this exotic plants. In forest, people are planting eucalyptus, very unfortunate for commercial purposes. Once eucalyptus is there, groundwater gone, no biodiversity, all animals will come to Warangal. Warangal means all monkeys will come to Warangal. Even forest, cheetahs and everybody is coming. Why they are coming here? There is no food, no. We are having over food. Do you think or not? Do you accept my words? We are having more food. There is a ajirti or there is no akali. Don't only you are having lot of biryani, red biryani. What is that, sir? Bucket, red bucket, yellow bucket, all buckets are there. So this is what is happening. But there is no food for animals. We need to think. Okay, thank you very much, sir.
Why don't you develop that trees in huge quantities by using the tissue culture technique?
Sir, tissue culture is a different one. Tissue culture is plants are very sensitive, sir. Actually, don't destroy the nature. First thing, what the human tendency, sir. If you are having hot water and a luxury bathroom, you will take bath for 2 hours, 1 hour. Right? Means lot of shampoo, lot of soap you will use. No. Natural resources, we need to first stop. Means destroying the natural over usage, we need to stop. Then what sir said is important. What is that? Like tissue culture based thing, like you can grow that, but again you have to adopt them, or they have to adopt the nature in the physical nature. That's why, sir, now the deshi seeds are important. Deshi seeds, like balls, what you call mud balls, people used to prepare and throw it. Don't destroy forests, sir. That's the only key.
Actually, before the extinction of the one precious tree, you can follow the tissue culture technique. However, tissue culture technique is not acceptable because it is very loose technique. But
no, that is happening, sir. That is happening, but people are, where money comes, I want to invest my time and energy and my tissue culture there only. People are not worried about nature. That's the problem. If one hai to mujhe kya fayda hai? That's the only the tendency of the nature. Otherwise, tissue culture lab, maintaining tissue culture lab itself is a problematic thing. Yeah, that's all. No, sir. Governments are nothing.
Tissue culture and gene bank.
Gene bank.
Actually, the government is protecting whatever the
endangered species.
The gene is protected. But when it comes to this tissue culture, in that tissue culture, the scientists are doing experiments to transfer the gene, different gene. So different character gene is transferred to the tissue culture plant, and they are producing the new variant. New variant. That is tissue culture experiment. But the gene bank is important. achieved for to survive the particular species of the particular plant, which is very important. The central government doing that work.
So conservation is happening, ex situ, in situ, herbal gardens, that is happening, but not to that extent what is required, because all is with money. Funding. Research is funding, sir. Research, who wants to go into research, they should be very careful, 10 years, 15 years it will take. No, it is a good field, but you should be careful. Immediately money you may not get, youngsters. Passion should be there, but immediate money, little bit problem. Passion is there.
But when compared to the plant growing in sunlight and without sunlight, the phytochemicals are completely different. Completely different. And just avoid that plant. Just nature is completely different from the laboratory. So the light, when the light is exposed on that particular leaf, the components of that particular plant are completely changed. The structure of that particular compound structure. For example, vitamin A, vitamin D. So where is vitamin D? Students, please. Vitamin D eక్కడ ఉంటుందమ్మా? Sunlight లో ఉండాలి.
Vitamin D is in our body, not in the sunlight.
అదే కదా, అందుకే సన్లైట్ ఇక్కడ ఎర్గోస్టిరాల్ is a fat that is chemical that is ergosterol is present on the skin. If the photons of that light interact with this ergosterol, that ergosterol is converting into vitamin D. What is vitamin D chemical name? Calciferol. Calciferol, calciferol. D3, D4. ఎక్కడున్నారు 10th క్లాస్ లో ఉన్నది విటమిన్ డి. డిగ్రీకి వచ్చి మీరు విటమిన్స్ తెలుసుకోకుంటే ఇవన్నీ ఎందుకు అమ్మాయి నేర్చుకోండి, చదువుకోండి. సో కాబట్టి ది నేచర్ ఈస్ కంప్లీట్లీ డిఫరెంట్. ది నేచర్ కెన్ చేంజ్ ఎవ్రీథింగ్. మనం ఈరోజు 120 సంవత్సరాలు మన పూర్వీకులు బతుకులు, బట్ ఇప్పుడు మనం 100 సంవత్సరాలు 70 సంవత్సరాలు బ్రతకాలంటేనే కష్టం. నేచర్ని మనం చెప్పేస్తాం, రైట్? సో దట్ ఈస్ మెయిన్ ఇంపార్టెంట్. కాబట్టి ది నేచర్ ఈస్ మోస్ట్ ఇంపార్టెంట్. ది సన్ ఎక్స్పోజింగ్ to that particular plant is most important to change the structure, to change the function of that particular plant. Right?
Like to increase our probability. Right, better.
Many thanks to Professor 𝕃𝕀𝕍𝔼 sir for his very valuable talk. And I also thank the technical session chair sir, Dr. Saisree sir. Now I request all the staff to come to state Professor 𝕃𝕀𝕍𝔼.
Students ఒక ఫోటో దిగండి సార్.
Now, how many oral presenters are here? 2 members.
వాళ్ళని